Given the function y equals 2x times cosine x, what is the value of dy dx? This is asking you to find the derivative of this guy right here with respect to x. What we have is we have two expressions multiplied together. So I'll call the first one, which is 2x, u, and I'll call the second one v. Now, a lot of people might use f's and g's, but I like u's and v's because I enjoy the sun's harmful rays. Now, this is going to require what's called the product rule. Okay, if I were to label that u and v, the product rule is going to be u prime v plus v prime u. So let's list out the fact that I know what u is, or u are. And if I want to find out what u prime is, I'm going to use the power rule and take the derivative of 2x, which is just regular old 2, no problem there. I called v cosine x. The derivative of cosine x, v prime, is negative sine x. So what I have to do is I have to put this all together, make it look nice and neat. So in this case, dy dx is going to equal u prime v, so 2 times cosine x, no problem so far, plus v prime, which is negative sine x, u, which is 2x. Now that doesn't look so great, so let me take one more step and clean it up. 2 cosine x, let's put plus negative and make that a minus. Let's bring that 2x out front and make u sine x. So the derivative using the product rule of 2x cos x is going to be 2 cos x minus 2x sine x, which is going to be b, baby. So yeah, fun stuff. Hope this helps. Let f of x equals 600x minus 2x cubed. On which of the following intervals is the function f increasing? So if I want to find out when a function is increasing, that means I care about when its derivative is going to be positive. So this is going to be a three-step process. Step number one, take the derivative, set it equal to 0, find the critical points. Step 2, use those critical points and make a sign table. And step 3, plug in some points to find out where things are going to be positive or negative. So let's find our critical points by taking the derivative. F prime of x. Power rule, power rule. The derivative of 600x is 600, easy peasy. Minus the derivative of 2x cubed is 6x squared. Now to find our critical points, what we do is we set this equal to 0. Critical points mean that we have a place where something changes from positive to negative, or increasing to decreasing, or vice versa, decreasing to increasing. So we care about this. Let's add 6x squared to both sides, like so, cross you out. 6x squared is going to equal 600. Divide both sides by 6, like so. X squared is going to equal 100. And in order to get x all by itself, we positive or negative square root both sides, giving us critical points at positive or negative 10. So here's my critical points. Now what I want to do is I want to make myself a sign table. So a sign table for f prime of x. All right. So I have two critical points. They were at negative 10 and positive 10. What I need to do is I need to choose 3 numbers on intervals here that are not negative 10 or positive 10. So what I want to do is I want to plug numbers in to see if it's positive or negative on that interval. I want to plug it into the derivative function. So I'll choose 0 because 0 is a nice number living in between negative 10 and 10. I'll choose negative 100 because why not, and positive 100 because you can't tell me what to do. Now what I have to do is I have to take turns plugging these 3 numbers into the derivative. If when I plug it in, I get a negative number, that means it's decreasing on that interval. And if when I plug it in, I get a positive number, that means it's increasing on that interval. So let's start out with f prime of negative 100. That's going to be 600 minus 6 times negative 100 squared. 600 minus, now let's do a little bit of quick math, negative 100 squared is 10,000. Negative 6 times 10,000 is negative 60,000. I don't care what the number is. I just care about the fact that this is negative. So since I get a negative number here, What that means is f prime, or f regular, the function, is going to be decreasing from negative infinity all the way up to negative 10. That's what this means. A negative derivative implies that the function is decreasing on that point on that interval. So let's do it again, and let's do it with 0. F prime of 0 is going to be 600 minus 6 times 0 squared, which is going to be 600 minus 0, which is going to be a positive number. So you're positive right here, which means my function is increasing between negative 10 and positive 10. Now let's just be on the safe side, make sure we get something that we want here. Okay, we'll plug in 100. So f prime of 100 is going to be 600 minus 6 times 100 squared. And what's going to happen is the same thing that we had up here in blue, or if you're colorblind, gray, and we get 600 minus 60,000, which is negative. So we are negative right here, which means that we are decreasing on the interval from 10 to infinity. So the only spot where it is increasing is where the derivative is positive, and that happens between negative 10 and positive 10, not including those numbers, because including those numbers would be saying, sure, the slope is 0, which means that's not true at all. It's neither increasing nor decreasing. So the answer to this guy right here is a lovely old B. So fun stuff. Hope this helps. What is the antiderivative of secant squared x with respect to x? Well, antiderivative is just fancy talk for integral. So this is asking for the integral of secant squared x dx. And this is just flat out memorization. Okay, hopefully you remember from the regular derivative parts that the derivative of tangent is secant squared x, so the antiderivative of secant squared x is tangent x. Now, since this is asking for the antiderivative, we attach an arbitrary c. Now, that arbitrary c means it could be any constant. So if I were to work backwards to check my work and take the derivative of tan x, I would get secant squared x. And if I were to take the derivative of some arbitrary constant, it just goes away anyway. So what we end up with is c, which means yes in Spanish. Hope this helps. If f of x equals 9x minus 5 plus ln of x, then find f prime of 1. This is asking you to take the derivative, and then once you take the derivative, you plug in 1, see what number you get. Now, got three things going on here. Okay, so f prime is going to be the derivative of 9x, which is just regular power rule, and the derivative of 9x is just 9. Then you have the derivative of negative 5, which disappears, nothing at all. And then you have the derivative of ln of x, which becomes positive 1 over x. So that's what f prime is. Now to complete this problem, we take 1 and plug it in for every x. So 9 plus 1 over 1 is going to be 9 plus 1, which is 10. So if f of x equals 9x minus 5 plus ln of x, then f prime of 1 is 10. The answer is E. Thanks for watching. The graph of the function f is shown below. Which of the following statements is true? So we've got ourselves a crazy looking piecewise function. Lots going on, so we need to find the truth statement here. The limit as x approaches negative 1 of f of x exists. So here's negative 1. In order for the limit to exist at the constant number, the left-handed limit and the right-handed limit have to be the same. This is not the case. The left-handed limit approaches 0, the right-handed limit approaches 1, which means the limit as x approaches negative 1 does not exist. The answer is not A. Let's take a look at B. The limit as x approaches regular 1 exists. Same exact problem. Okay? As the left-handed limit approaches 1, it approaches 1. So that was kind of redundant, but I like what I said. As it approaches 1 from the right side, it approaches 2 as an f of x value. That's not the same. And if you're looking at this point down there and wondering what that means, absolutely nothing in this case. Absolutely nothing at all. So since the left-handed limit and the right-handed limit don't match, that's not going to be it either because it's not going to be true. Let's take a look at C. f of x is differentiable at x equals 2. Differentiable means you're allowed to take the derivative at that point right there. Well, if you have a sharp corner or a cusp, okay, you cannot take the derivative at that point. So since 2 has this sharp corner going on right here, that means 2 is not differentiable, or at least we could say f of x is not differentiable at 2, so C is not a viable option. So lots of lies so far. D says f of x is differentiable at x equals 4. Well, at x equals 4, we have ourselves a constant slope. No cusps, no sharp corners, everything seems to be fine. So this is going to be my true statement because at that moment you are on a continuous, constant slope. So D is true. Now let's just take a look at E because why not? Let's throw an extra minute or two into this problem. The function f is continuous at 1. At 1, you can see that it's broken up into 3 different pieces, so that's definitely not going to be true, so E ain't it. So it's got to be D, which is very similar to what NSYNC said when they said it's got to be me. Or it's going to be me. Oh, crap. Thanks for watching. A particle moves along the x-axis. Cool. The velocity of the particle at time t is given by v of t equals at minus 2t squared, the velocity function. What is the total distance traveled by the particle from time t equals 0 to t equals 4? This is the annoying part about distance problems. Distance and displacement are not the same. Displacement is easy. Distance is not. Like, for example, if I were to go forward like 10 feet, backward like 4 feet, the displacement is 6. The distance is 14. So what we need to do is we need to account for any changes in direction. So what we're going to do is we're going to take the velocity function and find the critical points using the velocity function and pretending that that is already the derivative. So we set u equal to 0. 0 equals 8t minus 2t squared. Let's factor out a 2 and a t, and that gives me 4 minus t, and so my critical points just so happen to be 0 and 4. So I don't have to worry about any changes of direction because any changes of direction would happen at 0 or 4, and my interval is only between 0 and 4, so I don't need to worry about that. That makes life a whole lot easier. So now what I do is, since I have the velocity function, the position function is going to be the integral. So I'm going to integrate 8t minus 2t squared dt between 0 and 4. So the integral of 8t is going to be 4t squared. The integral of negative 2t squared is going to be 2/3 t cubed. And then my limits of integration are going to be 0 and 4. Okay? Now it's just some gross math, so this is not going to be pleasant. Not pleasant at all. That's okay. We're going to have 4 times 4 squared, like so, minus 2/3 times 4 cubed, like so. That's not fun, but this part's going to be kind of easy. 4 times 0 squared minus 2/3 0 cubed. So we all know what's going to happen here. 0 squared times 4 is 0, 0 cubed times blah, 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 0. This whole thing becomes 0. So now I just need to focus on the left side right there. All right, so 4 times 4 times 4 is going to be 64 minus 2/3 of 64. And I believe, no, that's not going to be pretty at all. I was hoping it would be. Let's turn 64 into something over 3. So that would be 64 times 3 is 192 over 3 minus 128 over 3. And so 92 minus, that's 64/3. Oh, I should have done that. I should have known that. 64/3, which is going to be B. Gross. So not the easiest problem on the planet, but again, yeah, that's how you would do it. It's just this part right here just ended up being nice. That made life a lot easier. So thanks for watching. Given the function y equals ln of x plus 3x squared minus tan x, all taken to the fourth power, what is y prime? Well, this is chain rule. So with chain rule, you are given y equals some type of outside stuff. That's not how you spell outside. That's how you spell outside. And you have some type of inside stuff. And that's what we have here. The outside is 2 to the fourth. The inside is that mess right there. Take the derivative of the outside stuff. Okay, so the outside derivative, keep the inside stuff exactly the way it is, but then multiply everything by the derivative of the inside stuff, like so. So, y prime is going to be equal to the derivative of the outside, which involves me dropping that 4 down out front and subtracting 1 from 4. Keep the inside, so ln of x is still ln of x. Plus 3x squared is 3x squared, and minus tan x is tan x. But then we're going to multiply everything by the derivative of the inside stuff. The derivative of ln of x is 1 over x. The derivative of 3x squared is 6x. The derivative of negative tan x is negative secant squared x. So that would be, let me see, all of these have the 4 out front. You're no good. To the third power, good. Then we have 1 over x, nope. 1 over x plus 6x minus secant squared x. So it's going to be c. I don't like how they're so very similar, but yeah, it's going to be c because we did chain rule. Fun. A tank contains 75 liters of water at time t equals 3 hours. Water is being pumped into the tank at a rate r of t, where r of t is measured in liters per hour and t is measured in hours. Selected values of r of t are given in the table below. So we have t equals 3, 4, 6, and 9, so those are not constant, that's great. And r of t just goes down kind of nicely, that's fine. Using a right Riemann sum with 3 subintervals, what is the approximation of the number of liters of water that are used in the tank at time t equals 9 hours? All right, so let's kind of draw a very, very, very poor picture of what this could look like. Here's 3, right? Here's 4, here's 6, here's 9. Okay, at 3 we're at 10. Okay, at 4 we're at 8. All right, at 6 we're at 7, and at 9 we're at what is that, 6. Right Riemann sums are going to take the right side of the triangle. So we are going to calculate not that one, but that one, and that one. Okay. We're using, now again, if you're wondering like, why not that first one? Well, we start at 3, so really none of this is important. We are going to calculate these 3 rectangles. Now normally what we would do is we would take the change, we would subtract a number, we would divide by 3, but that's not what we're doing here because we kind of have all the numbers that we need. We know that between 3 and 4, you are a length of 1 with a height of 8. So I'm going to use that. Okay, I know between 4 and 6, you are a length of 2 with a height of 7. And between 6 and 9, you are a length of 3 with a height of 6. So I'm going to calculate the 3 areas of these rectangles right here. 1 times 8 plus 2 times 7 plus 3 times 6. Now 8 plus 14 plus 18 is going to be 40. Now if you're like, 40, that's my answer. No. 40 is what we get between 3 and 9. Okay. What we also have is the fact that it already has 75 liters in it. So there's 75 liters plus the 40 that we gain using the right Riemann sums is going to give us 115. So kind of a very tricky problem, a very bizarre problem, not fun at all. Riemann sums aren't everybody's favorite, but that's how I did it. And that's the answer. Fun. Let f be the function defined as follows. We have ourselves a piecewise function. F of x is 2x plus 1, but we only care about that for when x is less than 2. We have just a constant k, which we don't know, for x equals 2, and x minus 2 over x minus 2 for x is greater than 2. So basically, what we need to do is we need to find out what k are going to make these guys continuous. Okay, so for this one, if I were to plug in 2, because keep in mind, we have ourselves a piecewise function, okay? Magic happens at 2. Okay, at 2, I don't know what's going to happen, but I have 2x plus 1, which is going to look like that. It's going to stop right there. I have u, which is going to look like some kind of straight line because it does simplify and cancel out, but even though 2 is against the rules, I don't care about 2 being against the rules. This just ends up being 1. Okay, so whatever that's going to look like, hopefully it looks like that. And then we need to find a k that connects these guys together. But in order for me to do that, I need to find out what happens at 2. So for this first one, if I were to plug in 2, I would get 2 times 2 plus 1, which is 5. And we just determined that this guy down here is 1. So this picture that I drew over here is completely wrong. This is going to happen right there. So how are we going to connect these guys? Well, we can. There's no number that's going to connect these two. There's no number that's going to make that jump all the way down there, which means no value of k is going to make this continuous at x equals 2. So kind of a tricky problem, but that's how you do it. What is the area of the region in the first quadrant bounded by the graph of y equals e to the 2x and the line x equals 4? Quadrant 1 only. So let's draw quadrant 1 only. E to the 2x looks a little something like this. Okay, so you care about stuff that happens between 0, because it's first quadrant, and 4, because it's that. And so we need to find the area trapped in here. Well, that's just the integral. I mean, if you're thinking about area between curves, that's okay, but that's just the integral. So I'm going to take the integral from 0 to 4 of e to the 2x dx. Now this is going to be integration by u substitution. So let's let u equal 2x, which means du dx is going to be 2. And if I flip-flop the dx and the 2, that ends up making du over 2 equal to dx. So the integral that I can set up now is my limits are 0 to 4, and those are the x values, by the way, not u values, of e to the u du over 2. So let's pull out the 1/2 before I do anything, because there's no need to keep that there. 0 to 4 e to the u du. The integral of e to the u is e to the u, so I have 1/2 times e to the u, where my limits are still 0 and 4, but again, those have to do with x. So now I need to plug the x back in. Since I let u equal 2x, I now have 1/2 e to the 2x, where my limits are 0 and 4. All right, so let's plug those in. 1/2 e to the 2 times 4 minus 1/2 e to the 2 times 0. Which is 1/2 e to the 8th minus 2 times 0 is 1, so 1/2 e to the 1 is 1/2. And what I could do here is I could pull out the 1/2, and I'm left with e to the 8 minus 1, which is going to be b. Find the equation of the line tangent to f of x equals 3x squared minus 8 and x equals 2 in point slope form. So what I have to do is I have to find the slope, which is f prime of x. That's going to give me slope. So let's find f prime of x, shall we? F prime of x is going to be dropped down to 2, 6x minus 8 just disappears. Now at x equals 2, the slope at that moment right there is going to be f prime of 2, which is going to be 6 times 2, which is 12. So my slope is 12. Now, I'm given the x value. If I'm thinking point slope form, I'm like, oh cool, I have a slope, but I only have half a point. So I need the other part of the point, which is found by me taking 2 and plugging that into the original f function. So 3 times 2 squared minus 8 is going to be 3 times 4 minus 8, which is going to be 12 minus 8, which is going to be regular old 4. So if I have a slope of 12, and now I have a point of 2, 4, I have enough information to make point slope form. So point slope form is y minus y sub 1 equals m times the quantity x minus x sub 1. You would be my m, you would be my x sub 1, you would be my y sub 1. So all I have to do is just plug stuff in. Y minus y sub 1 is y minus 4 equals m, which is 12, times the quantity x minus x sub 1, which is 2. And that's going to be A, baby. All right. A. Okay. Evaluate the integral of e to the x squared times 2x. Well, in a problem like this, since it's obviously going to be integration by u substitution, we want to choose a u such that we see its derivative floating around somewhere in the problem. The derivative of x squared happens to be 2x, so I'm going to let u equal x squared, which means du dx is going to equal 2x. And if I flip-flop the dx and the 2x, I get du over 2x equals dx. So now I can rewrite this. Now I can rewrite that over here as the integral of e to the u, since I let u equal x squared, e to the u, times 2x, and instead of dx, du over 2x. And just like that, the 2x and the 2x cancel each other out, leaving us with the indefinite integral e to the u du, which is going to be e to the u plus c. And the last step is replacing u with x squared, so e to the x squared plus c, which is going to be a. Not bad. Let f of x equal x squared minus 3x minus 1 and g of x equals 2x plus 1. What is f prime of g of negative 2? Well, let's start out by finding out g of negative 2. G of negative 2 is going to be 2 times negative 2 plus 1, which is going to be negative 4 plus 1, which is going to be negative 3. Now that I have that, I can find f prime of negative 3. So f prime of x is going to be 2x minus 3, because power rule and power rule. So f prime of negative 3 is going to be 2 times negative 3 minus 3, which is negative 6 minus 3, which is negative 9. And that's your guy. Use the graph of f of x below to calculate the integral from 0 to 12 of f of x dx. So again, what is the value of the integral from 0 to 12 of f of x dx? So basically, I'm not given the actual formula. I'm given a picture. Now remember, the integral from whatever to whatever is the area under the curve. So I'm looking at this and I'm noticing, wait a minute, I have 3 shapes. I have that shape right there, like a triangle, a nice perfect looking triangle. I have that shape right there, a nice perfect rectangle, and I have that shape right there, a nice right trapezoid. So let's focus on the triangle first. Okay, this is a triangle that has a base of 5 and a height of 5. Okay, so the area of a triangle is half times base times height. So in this case, half times 5 times 5, which is going to be half of 25, that's a 5, which is going to be 12 and a half. All right, cool, I can handle that. This second shape is going to be a rectangle with a height of 5 and a length of 3. So the area of that is a rectangle, which is length times width. So 3 times 5, which is 15. Much more manageable. This last guy is a right trapezoid with a height of 5 over here, and then technically a base of 5 over here. We have a height of 4, and a second base that goes up to 7. So the area of a trapezoid is I guess we could say 1/2 of the height times base sub 1 plus base sub 2. Okay, So 1/2 of the height, which is 4, times base sub 1, which is 5, plus base sub 2, which is 7, which is 1/2 of 4 times 12, which is 2 times 12, which is 24. So we take those three numbers, 12.5, 15, 24, we add them all up, that'll get us 51.5, and 51.5 is C. Pretty easy. Given the function h of x equals 4 cos quarter pi x minus 1, which of the following statements is true regarding h of 6, h prime of 6, and h double prime of 6? All right, so we got to figure out each one of these guys and see what we get here. So let's take a look at h of 6. h of 6 is simply saying, what is the value when you were to go over to 6 and plug it in? Well, it looks like h of 6 is going to be -1. So you get that point right there. H of 6 is going to be -1. Cool beans. H prime of 6 is the slope at 6. So we go over to 6, and it looks like right around here, it looks like the slope is probably like 2-ish. So we'll say that h prime of 6 is going to be 2-ish. We don't know the absolute number, but it's going to be somewhere in that area. It's kind of steep. Maybe it's like 1.5 or something. I don't know. I'm going to go with 2-ish right there. Okay. Now, h double prime of 6 has to do with concavity. And in this case, if I were to put a dot there, it looks like there's a change in concavity, which means you are an inflection point. So h double prime of 6, since it's an inflection point, is 0. That's where concavity changes. So what I have is I have h of 6 is definitely negative, h prime of 6 is definitely positive, and h double prime of 6 is 0. So the smallest of these is h of 6, and then right in the middle is h double prime of 6, and then after that is h regular prime of 6, which is going to be B. The position of a particle is given by the equation S of t equals at squared plus bt, where a and 0, a and b are not the same. When is the particle at rest? Well, the particle is at rest when the velocity is equal to 0. Now we find the velocity by taking the derivative of the position function. So we want to know when the derivative of that guy is equal to 0. So let's take the derivative of that guy with respect to t. Now we don't have regular numbers, we have a and b. Okay, where neither of those guys are 0. So if I were to take s prime of t, the derivative of at squared has me dropping the 2 down, leaving a there, and then t squared becomes t. The derivative of bt is just going to be b. Now, if I were to take that and set that equal to 0 and solve it for t, it's just basically a literal equation. Okay, so we would subtract b from both sides like this. So negative b equals 2at. Divide both sides by 2a. Divide both sides by 2a. And t is going to equal negative b over 2a, which looks like u. So a weird problem, a strange problem, but not that bad. Given that f of x is the integral from 2 to x of g of t dt, and the graph of f of x is a linear equation with a positive slope passing through the x-axis, what could be the graph of y equals g of x? All right, f of x is linear with a positive slope. That's very important. So if it's linear with a positive slope, it could look something like y, I shouldn't call it y, I should call it f of x equals, I'm just giving examples here, something like f of x equals 3x plus 2. Or f of x equals 10x minus 5, whatever. I'm just making stuff up. But What I do know is if I'm given this information right here and I need to find g of t, f prime of x, taking the derivative of both of these gives me g of t. The derivative of the integral gives me g of t. So I have to take the derivative of both sides here. So f prime of x is going to get me regular g of t, which is what I want. Okay, now yes, it says g of x, but after you integrate and then take the derivative, it becomes g of x, which is awesome, which is fine. Taking the derivative of any of these guys is just going to leave me with a positive integer. Like taking the derivative of f of x here would be 3. So like f prime would be 3. Or f prime would be 10 in this case. F prime of any linear equation with a positive slope is just going to be a positive number. So the graph is always going to look like a positive constant number, which is going to be something that looks like this, which is a horizontal line above the x-axis. So kind of a tricky problem, but yeah, that's how you do it. Find the value of the following limit. So you're given the limit as h approaches 0 of ln of 5 plus h minus ln of 5 all over h. Well, if you're wondering, boy oh boy, this looks a lot like this guy. The limit as h approaches 0 of f of x plus h minus f of x all over h. You're absolutely right. That's the derivative by limit formula. So you're basically comparing these two. And in a sense, if you notice this guy right here, ln of 5 and f of x, that means f of x is ln of x at x equals 5. So that's what we're trying to do. We are trying to find the derivative as x approaches 5. Not as x approaches 5, but when x is 5. So let's take the derivative of ln of x. So f prime of x is going to be 1 over x. Let's plug in 5. F prime of 5 is 1 over 5. And that's our guy. So not a difficult problem, just the way it's worded made it seem a whole lot worse than it had to be. For the function f of x equals x minus 2 over x plus 2, find the x values where the slope of the tangent to the curve is 1/4. Well, the slope of the tangent to the curve means f prime of x. That's the derivative. And we want to find out when f prime of x is equal to 1/4. So we need to find the derivative of that guy, which involves quotient rule. So quotient rule is u prime v minus v prime u over v squared. I know a lot of teachers might do the high d low and the f's and g's and stuff like that, but I just do it this way. U is the numerator, so x minus 2. V is the denominator, so x plus 2, which means u prime is going to be the derivative of u, which is 1, and v prime is going to be the derivative of v, which is also 1. But v squared is going to be x plus 2 in parentheses squared, which I'll probably have to multiply out at some point, but we'll worry about that when we have to worry about that. All right, so let's put it all together. F prime of x is going to be u prime v, so 1 times x plus 2 minus v prime u, so 1 times x minus 2 over x plus 2 squared, and that's going to equal 1/4. Okay, the derivative equals 1/4 in this problem. That's the point. That's what we're solving for. All right, so multiplying 1 to everything is just going to be x plus 2, no loss of sleep over that. Negative 1 to everything is going to be minus x plus 2. And then multiplying all of this out is going to be x squared plus 4x plus 4 because perfect square trinomials. That's going to equal 1/4 again. All right, and last time I checked, 2 plus 2 is 4. And so you can stay x squared plus 4x plus 4 equals 1/4. Now what we could do is cross multiply. So 1 times u isn't going to change anything. So x squared plus 4x plus 4. 4 times 4 is 16, so equals 16. Let's subtract 16 from both sides. So that gives us x squared plus 4x minus 12 equals 0. That should factor out nicely to x minus 6, nope, x plus 6, x minus 2 equals 0, which means our magic numbers are going to be x equals negative 6, x equals positive 2. That's how you do it. Let f of x equals parentheses 4x minus 5 close it square it, and let g be the inverse function of f. Given that f of 0 is 1, what is the value of g prime of 1? Well, if we're talking about inverses and its derivatives, we have a little formula that says that g prime of x is going to equal 1 over f prime of g of x. Like so. All right, so since f and g are inverses, it says it right there, since f and g are inverses, and we are told that f of 0 is 1, that would mean to flip it around for inverse stuff, g of 1 would equal 0. So, in order to find g prime of 1, we start out by saying f prime of g of 1, right? And so that g of 1 inside the parentheses, g prime of 1, is going to be 1 over f prime of 0. So now what we need to do is find out what f prime is. So let's go off to the side and do that so I don't have to worry about thinking, all this fraction grossness. F prime of x is parentheses 4x minus 5 close it square it. Now you could FOIL that out, but I'm going to just use chain rule because I'm going to end up plugging in 1 anyway, or 0, I'm sorry. I'm going to end up plugging in 0 anyway. So chain rule has me drop the 2 down, take the derivative of the outside, which means drop the 2 down. The derivative of the outside makes it look like that. 2 becomes invisible 1. Keep the inside, but then multiply everything by the derivative of the inside. The derivative of the inside would be 4. So f prime of x becomes 8 times 4x minus 5. Now f prime of 0 is going to be 8 times 4 times 0 minus 5, or 8 times negative 5, which is negative 40. So f prime of 0 is negative 40. So g prime of 1 is 1 over negative 40. And that's u. Isn't that neat? The line y equals 3 is a horizontal asymptote to the graph of which of the following functions. Now, those of you who know my expertise, it's AP Pre-Calculus. And we are taught that if I have something where you have the same degree over the same degree, like for example, something like 3x to the 4th plus blah, blah, blah over x to the 4th plus blah, blah, blah. If you have something like that, if the degree on the numerator is the same as the degree in the denominator, you take the leading coefficients, so 3, invisible 1, and your horizontal asymptote is going to exist at the leading coefficients over the leading coefficients as long as the degree is over the degree. So what I want to look for is something that has the same degree over the same degree, where the leading coefficient up here is 3 and the leading coefficient down here is 1, and that way I'll get the horizontal asymptote at 3. Does that happen here? No. Okay, this gives you a horizontal asymptote at 0 because the denominator has a larger degree. You're not going to work out. You're a linear equation, which means you're not even going to have a horizontal asymptote. Okay, you're sine of 3x, which means you look like that, so you're not going to have a horizontal asymptote. You're a linear equation. It's going to look something like this. You don't have a horizontal asymptote. You have 9x squared up here and 3x squared down there. So the degrees in the numerator are the same as the degrees in the denominator. So you focus on the leading coefficient over the leading coefficient, which is 9 over 3. That divides out to 3, which means your horizontal asymptote exists at y equals 3. And that's how you do that one. Let f of x equals negative 3x squared plus 6x minus 5. What is the absolute maximum value of f of x? Well, in order to find the absolute maximum value, we have to find its critical points. Critical points will tell us whether or not we have a maximum or a minimum, and then we can go from there. So how do you find critical points? Well, you take f prime of x and then set it equal to 0. So f prime of x is going to be the derivative of u, so negative 6x plus 6 plus 0. So set u equal to 0, like so. Subtract 6 from both sides. Negative 6 equals negative 6x. Divide both sides by negative 6. Divide both sides by negative 6, and positive 1 equals x. So the critical point is going to be 1. Now, what a critical point does is it tells you where your slope is 0. So if your slope is 0, that means you're going to either have a maximum, because our slope is 0, or a minimum, as long as there's a sign change. So we're going to make a sign table and make sure that there is a sign change. So at 1, we have a critical point. This is the sign table for f prime of x. So what I need to do is, since I only have one critical point, I have an interval of negative infinity all the way up until 1, and then from 1 all the way up until infinity. So I'm going to take a number like 0 and plug it into f prime of x and see if I get a positive or negative number. If it's positive, that means my function f of x is increasing. If it's negative, that means my function f of x is decreasing. I'll also plug in 2, because that's some number in the interval from 1 to infinity. So f prime of 0 would be me taking that equation right there and saying negative 6 times 0 plus 6 is going to be 0 plus 6, which is a positive number. So you're positive, which means you are increasing. F of x is increasing. Now we do it again. F prime of 2 is negative 6 times 2 plus 6, which is negative 12 plus 6, which is a negative number. So what's happening here is f of x is increasing, but once it hits x equals 1, it hits a peak up here and then starts decreasing. So we definitely do have a maximum. Okay, I just wanted to make sure of that. We definitely do have a maximum value at x equals 1. In order to find out what that maximum value is, you plug 1 into the original equation, not the derivative, because the derivative will give you 0. You plug it into the original equation because that tells you where it exists on the original function f of x. So regular f of 1 is going to equal negative 3 times 1 squared plus 6 times 1 minus 5. So negative 3 times 1 squared is going to be negative 3 times 1. 6 times 1 is going to be 6 minus 5. Negative 3 plus 6 is regular 3. 3 minus 5 is going to be negative 2. So our maximum value is going to happen at the point 1, negative 2. And so the answer is C. All right, get ready for a pretty easy question, but it's potentially confusing, and so a lot of people get this wrong. If P of t represents the size of a population at time t, which of the following differential equations describes linear growth in the size of a population? A linear equation is in the form y equals mx plus b, where m can be any number as long, in this case, as it's not 0, right? B can be 0, who cares? Which means if P of t is supposed to be linear growth, right? And so linear growth also means that m in this case has to be greater than 0. We are looking at something where P of t has to be in the form m times, and we won't use x, we'll use t, plus b. And in the same vein, m has to be greater than 0. Okay? So that's linear growth, which means in order to take the derivative of that, okay, we would get the derivative, which is dp dt, is going to equal the derivative of m times t is just going to be m, and then the b disappears because, a constant just goes away. So the derivative is just going to be some integer greater than 0, like 5. Okay? So again, you're looking for P of t being linear growth, which means it's got to be in the form y equals mx plus b. So when you take the derivative of it, you end up with just a regular constant that is a positive number, which is why this is the one that works. I think a lot of people would look at this one and circle that one immediately thinking, oh, well, that's linear, like y equals mx plus b. No, sir, no, ma'am, that's not how it works. Let g of x equals x times e to the kx, where k is a constant. For what value of k does g of x have a critical point at x equals 1? All right, so critical points exist when g prime of x is going to be equal to 0. So that's what we need to deal with first. Since g of x is x times e to the kx, this is going to involve product rule. Product rule is u prime v plus v prime u. So what I need to do is find out if I label u as x and if I label v as e to the kx, u would be x, v would be e to the kx, right? U prime is 1. V prime is going to be, take the derivative of the outside stuff, which is still just e because the derivative of e to the whatever is e to the whatever. Keep the inside, which is kx. But since k is a constant, multiplying everything by the derivative of the inside would be me like taking the derivative of 2x or 4x, which is 2 or 4, or in this case, k. So now, g prime of x is going to equal u prime v, so 1 times e to the kx, plus v prime, so k, e to the kx, times u, which is x. So let's clean this up a bit. E to the kx plus kx e to the kx. Now, g prime of 1 has me substituting 1 for every x. So e to the k times 1 plus k times 1 e to the k times 1. So e to the k plus k e to the k. Now I want to set g prime of x, or now g prime of 1, equal to 0. So let's set u equal to 0. I have an e to the k in common with both. Okay, so let's factor out an e to the k, and that leaves me with 1 plus k. Now you use the zero product property and set this up as two separate equations, all right? E to the k equals 0, and 1 plus k equals 0. Well, what value of k, if I were to use it as an exponent, would get me 0? Nothing. This is exponential. There's no number that will, if I were to plug into k, would get me 0. It's impossible, so you're an impossibility. This guy, all I have to do is just subtract 1 from both sides, and k equals -1, which is going to give me b. So a very, very, very bizarre problem. Very bizarre problem, but that's how you would do it. Solve the differential equation dy dx equals 4 cos x with the initial condition y of 0 equals 4. What is the solution? Well, if I want to get the solution, if I want to get y of x, what I'm going to do is integrate both sides here, because the integral of a derivative gets it back to its original function. So this would give me y of x. So y of x is going to equal the derivative, or I'm sorry, the integral of 4 cosine x dx. Okay? Now the integral of 4 is just 4. The integral of cosine is sine x, no negatives to worry about. But since this is an indefinite integral, I have to attach plus c there. All right, so y of x equals 4 sine x plus c. What do I know? Well, it tells me right here that y of 0 is 4. Here's y of x. So if I want to find out what c is, I'm going to replace x with 0. So 4 times sine of 0 plus c. Okay, sine looks like this. So sine of 0 is 0. So y of 0 is going to equal 4 times 0 plus c. And by the way, y of 0 is 4, so 4 is going to equal 0 plus c. So c is 4. So taking this guy right here and this little piece of information right here, we can come up with the equation y of x equals 4 sine x plus 4, which is u. Let g of x be a function with the first derivative given by g prime of x is the integral between 0 and x of e to the negative 4t dt. What is true about the increasing, decreasing behavior and concavity of g of x on the interval between 0 and 2? All right, well, generally speaking, okay, e to the negative 4t is going to be exponential decay. Looks something like this, right? Of course, the picture that I drew is awful, but what will happen is this guy will never, ever, 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 ever touch the x-axis. So what we're basically saying is the derivative, or at least this guy, is always going to be positive. Now, if the derivative is always positive, that means g of x is always increasing, okay? So since this is always positive, that means the integral, the area underneath the curve between 0 and whatever x, is also going to be positive, okay? And if the integral is positive too, that means g of x is increasing between 0 and 2, okay? So it's going to be increasing, which means nope, nope, and nope. Now we need to take a look at concavity. Concavity exists at g double prime of x. Okay, so if I were to take the derivative, so let me just kind of draw this out. G prime of x is equal to the integral between 0 of x e to the negative 4t dt. If I were to ddx both sides, or yeah, it would be ddxing both sides, right? That would be me finding the second derivative. Now what that would do is that would give me g double prime of x, and the derivative of the integral kind of just cancels each other out. So g double prime of x is just e to the negative 4x, which reverts back to this picture right here. Now that picture, even though the picture is drawn poorly, sure looks like the left side of concave up, doesn't it? Sure looks like the left side of concave up. So we can say that this is concave up. So since g of x is increasing and g of x is concave up, we could say that my answer is going to be B for this one. So very tricky problem, and this is towards the end of the multiple choice section of these guys. You're going to start running into weird problems. This is one of them. Not fun, but we did it. Oh boy, this one's going to take a minute. Given the equation x squared plus 2xy equals y squared, determine the value of the second derivative at the point 2, negative 1. So this is implicit differentiation. So we're going to ddx both sides. We're going to ddx x squared plus 2xy equals the ddx of y squared. Remember, when you take the derivative of an x, no big deal. Take the derivative of your x. If you have to take the derivative of the y, you take the derivative but attach a dy dx or a y prime. I'm going to use y prime. This guy right here is product rule. 2x times y is product rule. So I'm going to let u equal 2x. I'm going to let v equal y. U prime is going to be 2. And v prime is going to be the derivative of y with respect to x, which is dy dx, or just y prime. So the product rule is u prime v, so 2 times y, so plus 2y, plus v prime u, which is going to be y prime 2x. And I know I'm writing that out of order, but I want to write it out so that the y prime is next, or second, I guess. Now, let's move you to the other side, like so. And so the left side is now 2x plus 2y equals 2y y prime, 2y y prime minus 2x y prime. Factor out whatever you can on both sides. Factor out a 2 on the left, 2 times x plus y. Factor out a 2 and a y prime on the right. And that gets us y minus x. Divide both sides by 2. Divide both sides by y minus x. And y prime is going to be x plus y over y minus x. That's the first derivative. Now on to the second derivative, which requires me to do quotient rule. U is x plus y, v is y minus x, u prime is the derivative of the top, so the derivative of x is 1, the derivative of y with respect to x is y prime. V prime is going to be the derivative of the bottom. The derivative with respect to x of y is y prime, minus x is 1. And then v squared is going to equal y minus x squared. Let's see if we have to deal with that when we have to deal with that. Probably not, but we'll see. We'll see. All right. Quotient rule is u prime v minus v prime u over v squared. So let's go up here. Oh boy, I'm so scared that I'm going to run out of space. Sloppy. All right, u prime v, so y double prime is going to equal u prime v, so u prime is 1 plus y prime, v is y minus x, minus v prime, which is y prime minus 1, u, which is x plus y, over y minus x squared. Let's simplify that. Y double prime, let's do some foiling, is going to be 1 times y is y minus x plus y prime y minus xy prime. So not only, minus parentheses, gross, xy prime plus yy prime minus x minus y. And that's still all over y minus x squared. Let's distribute that negative. Y double prime is going to equal y minus x plus y prime minus xy prime minus xy prime. How nice. Minus y prime. How nice. Minus plus x plus y. So lots of stuff here disappears. All right, let's, oh, by the way, I forgot to write out over that. Again, I'm not changing u, not yet. Okay, so let's see what disappears. We've got the y's unfortunately combined, so u will become 2y up top. The x's disappear. The y primes disappear, and you become minus 2xy prime over y minus x squared. Now we know that y prime from over here is this. So you become 2y minus 2x times x plus y over y minus x all over y minus x squared. Now would be a good time to finally plug in that point right there. All right, so y double prime at that point is going to be 2 times negative 1 minus 2 times 2, parentheses, 2 plus negative 1 over negative 1 minus 2, all over negative 1 minus 2 squared. Oh boy, I'm scared. Negative 2 minus 4, 1 over negative 3, so negative 1/3. And that's going to be over negative 1 minus 2, all of which is squared, so negative 3 is squared, so 9. So we've got negative 2 plus 4/3 over 9, which is negative 2/3 over 9, which means we multiply the top and the bottom by 1/3, so negative 2 over 27. Oh, thank you, Lord Jesus. Okay, whew. That was a nightmare. That was an absolute nightmare. And that took up a ton of space. But somehow we were able to do it, and thank you for bearing with me. That was gross. For t is greater than or equal to 0, which means time is greater than or equal to 0, the position of a particle moving along the x-axis is given by x of t equals cos t minus sine t. What is the acceleration of the particle at the point where the velocity is first equal to 0? All right, so this is the position function. So the velocity function is going to be the derivative of that. So x prime t is going to be the derivative of cos t, which is negative sine t, minus the derivative of sine t, which is cos t. Why I put that in parentheses and I didn't put that in parentheses, I don't know. But that is, so I have my velocity function. I care about when the velocity function is first equal to 0. So let's set that equal to 0. And so 0 now equals negative sine t minus cos t. Let's add cosine to both sides. So plus cos t, and we have cos t equals negative sine t. Let's divide both sides by cosine t to make it a tangent. So cosine t divided by cosine t, that's going to become 1, is equal to negative tangent t, which means tangent t is negative 1. All right, let me see if I can just give myself a little bit more space over here. You'll see why in a second. All right. Inverse tan both sides. Inverse tan both sides. And the inverse tangent of negative 1, think of it this way. Tangent means slope. So negative 1 is going to look like that. And so if you're thinking unit circle thoughts, right, it's going to first hit the negative 1 right there between pi over 2 and pi, which is 3/4 of a pi. So t is going to be 3/4 of a pi. Why would I put 0 down there? 3/4 of a pi. All right, so that's my t, which means gossip in slang. What is the acceleration of the particle at that point? So now I have t. I need to find the acceleration. The acceleration is the second derivative. So acceleration, right, is the second derivative. So x double prime of t, which is going to be the derivative of negative sine t, which is negative cos t, minus the derivative of cos t, which is positive sine t. So what I want to do is I want to plug in 3 pi over 4. So x double prime of 3 pi over 4 equals negative cosine of 3 pi over 4, unit circle thoughts, plus sine of 3 pi over 4. So we're looking at lots of root 2's and stuff. So u will become negative, and again, we're over here, so negative, cosine's the x value, negative root 2 over 2, plus sine is the y value, so that's going to be regular root 2 over 2. So the double negatives cancel out to become root 2 over 2, plus root 2 over 2. Root 2 plus root 2 is 2 of them, so 2 root 2 over 2 crosses out root 2. Bing, bing, bong. And just like that, we're done. So that ends the multiple choice, no calculator section of the GOAT exam. On to the calculator stuff. On to the calculator section. Now, the wonderful thing about the calculator section for these AP Calculus exams is you don't need a calculator for most of them. This is one of them. Use the graph of y below to answer the question. On what interval is the function only decreasing and concave up? No calculator is needed to stare at this graph and find out what function is only decreasing and concave up means. So decreasing just means it's going down to the right. Concave up means it looks like that. So if you want the combination of these two, little Venn diagram of this is going to be like your side is going to be the one that's concave up and also decreasing, because this is the one that's going down to the right and is also concave up. So between A and B is concave down, not even an option. Between B and C is concave up, but that's not only decreasing. Between B and C starts out decreasing, but then ends up increasing halfway through, so you're not an option. Between C and D is concave up and decreasing, so that's the one that we want. D and E is concave up and increasing. None of the above is not what I want. So this one is C because of what I said just a second ago. So calculator, fun? Yeah, for sure. Let f be a function that is continuous on the closed interval 4, 7, for f of 4 equals 8 and f of 7 equals 18. Which of the following is guaranteed by the intermediate value theorem? Now, this is a calculator section problem that doesn't require a calculator. The intermediate value theorem says that you must, if you're going to go from 4 to 7 and start out at 8 and end up at 18, you must pass through something in between 8 and 18. Okay, if this is continuous, right, you're going to have some type of graph. Now, we don't know what the graph is going to look like. But if this is 4, and this is 7, and this is 8, and this is 18, you start here, you end here. At some point, no matter what it looks like, at some point you're going to hit definitely between 8 and 18. So f of x must be 0. Nope, that's not an option. It doesn't have to be. It could happen, but it doesn't have to be an option. F of x has to be 10. Yep, because at some point we have to go from 8 to 18. Therefore, we have to hit 10 at some point. So yeah, B is going to be my answer. Have to hit 20? Nope, don't have to go beyond 18. The derivative has to be 5, and the derivative has to be positive. For the intermediate value theorem, there's nothing, no rule about derivatives. Like it just doesn't apply. So if you're talking about an intermediate value theorem problem and the options are the derivative is this, the derivative is that, the derivative is not guaranteed at all by the intermediate value theorem. So neither of these even matter. So the answer is B, because again, you have to hit 10 at some point between 8 and 18. The graph of 2e to the sine x minus 3 crosses the x-axis at one point in the interval 0, 1. What is the slope of the graph at this point? All right, so this is a calculator problem. What I need to do is I need to do two things, okay? I need to find out where this guy crosses the x-axis. So let's pretend that that's A. So in my calculator, I'm going to type that in, and I'm going to graph it, and I'm going to find the 0, and in my mind, call it A. It's going to be some crazy decimal. Then what I have to do is I have to find the slope at A. That requires the derivative. So the derivative of 2e to the sine x minus 3 is going to involve chain rule. So f prime of x is going to equal 2 is still 2, e is still e, right? Take the derivative of the inside, which is, we'll keep the inside first off. Let's do that. And multiply everything by the derivative of the inside, which is cosine. So I have cos x. Then minus 3 is minus 3. So what I'm going to do is I'm going to find out where this guy crosses the x-axis. Once I find out where it crosses the x-axis at some point called A, I'm going to take that number and plug it into 2 cos x e to the sine x. Once I get that number, that will get me my slope at that point. So let's go to the calculator and see what happens. All right. So step number 1 is to type out 2e, so the E button is second ln, right, to the sine x, which is sine x, close it, move to the right, minus 3. Now we hit graph, and we can see that this crosses the x-axis between 0 and 1 like it says it would. So let's find out what that value is that it crosses the x-axis. So second, calc, 0. I can just type out the left bounds because I care about 0 and 1. So 0 for the left bound, enter. For the right bound, I'll hit 1 because that's where I care about. And so that my guess is going to be enter. And I end up with 0.4174876. Now I'm going to use a bunch of those points as I do this next part. Now that I'm done that and I have my value, which, make sure you have it written down somewhere because you're going to need it. Okay, that's 0.417 blah, 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 blah. I'm going to do that and plug that into the derivative that I found earlier. The derivative that I found earlier was 2 cos x e to the sine x. So I'm going to plug in that number using as many decimals as I can. 2 cos. Now that number was 0.41749, 0.41749, okay, times, I just like to put the times there because it just separates everything, e to the sine x. So e was there, okay, sine of that same exact number, 0.41749, close it, and we end up with 2.7423, blah, 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 blah. So let's round that off and find out which one of our options seems to match that nicely. All right, so after all of that, we found out that at that point, that A value was 0.41749. More decimals than necessary. When I plugged that in, I ended up with 2.742, which seems to match up with B right here. Okay, so not the prettiest problem for sure, but yeah, that's how you do it. A particle moves along the x-axis. The velocity of the particle at time t is given by v of t, and the acceleration of the particle at time t is given by a of t. Which of the following expressions gives the average velocity of the particle from time t equals 0 to time t equals 6? All right. So what we need is to bring up the average value formula. Now, generally speaking, the average value formula is 1 over b minus a, the integral from a to b of f of x dx. If my job is to find the average velocity of the particle, what we're going to do is use the velocity function, okay? So that's going to involve us taking 1 over, now here would be my A, here would be my B, 1 over 6 minus 0 times the integral from 0 to 6 of the velocity function, v of t dt. So to simplify that, we get 1 over 6 from 0 to 6, v of t dt, and that gets us the average velocity of the particles. So there you have it. Now I know what you're thinking. You're thinking, well, wait a minute. In order to integrate, don't we integrate a of t? That's a good thought. That's a good thought, but you're finding the average velocity, not the average acceleration. So your heart's there, but that's not what you do in this case. Which of the following is true about f of x based on the graph of y equals f of x below? Well, this is a calculator problem that doesn't require a calculator. All right, so we're just looking at the fact that this graph is of the derivative. Okay, so using this information of the derivative, we should be able to talk about the regular function. Now remember what derivative gives us. Derivative gives us slope. So if the derivative is positive, it's a positive slope, which means it's increasing. If the derivative is negative, that means it's a negative slope, which means it's decreasing. If the derivative is 0, that means it's a maximum or a minimum. And it all depends. So let's look at each of these 3 options and see what those 3 options means in those contexts. Option number 1, okay, is asking what's happening between 0, 1, at 0 to 1, and also 3 to 5. It's saying f of x is increasing. Now, if f of x is increasing, that would imply that the derivative is positive, meaning the slope is a positive number. So if I look at this fact, I care about what happens between 0 and 1. So is the derivative positive between 0 and 1? And here's 0, here's 1. Is it above the x-axis? Yep, check. Also, is the same thing happening between 3 and 5? Is my graph above the x-axis between 3 and 5? Here's 3, here's 5, check. 1 is true, 1 is true, 1 is true, check. All right, let's look at the second option. F of x has a local minimum. Now, a local minimum occurs when you go from a negative slope to a positive slope. Why? Because if it goes from negative slope, if it's a local minimum, that means you're going down and all of a sudden it hits 0 and then you're going up, so you have a minimum. So am I going from negative to positive at 3? Well, here's 3. I am underneath the x-axis, which means, yep, right here it's negative, at 3, and then it becomes positive. So since my f prime of x is under the x-axis before 3, and then above after 3, that would imply that I have a local minimum. So this is a true statement, which means 2 is also true. Now 3 is talking about concavity. Okay, so what we're going to do is use a second derivative test, which is kind of difficult to look at, but let me explain. Okay, if we have something that's concave down, that means the second derivative is going to be negative. Now you can find, if you're like, well, this is the graph of the first derivative, I get it. Okay, but at 5, which is here, what we do is we look at the instantaneous rate of change of the slope. So in other words, the slope of the derivative gives us the second derivative. Since the slope of the derivative is negative, that means the second derivative is less than 0. So this is also a true statement. Okay, so all 3 of these ended up being a true statement, which means the answer is D. So calculator problem, no calculator needed. Fun stuff. Happy times. Water is pumped into a tank at a rate of R of t equals 25 times 1 minus e to the negative 0.12 t gallons per minute. Neat. T is the number of minutes since the pump was turned on. If the tank contained 1,000 gallons of water when the pump was turned on, how much water to the nearest gallon is in the tank after 10 minutes? So this is what we're going to do. We're given the rate, all right? The rate's not going to give us the amount of water after 10 minutes, but the integral of the rate is going to give us the amount of water after 10 minutes. So what we're going to do is we're going to run to our calculator and find out what that's going to be. And we're literally going to let our calculator do all the work. Once we find out that number, we add to the fact that we already have 1,000 gallons in the tank waiting for us. Add those numbers up, see what happens. So let's run to our calculator, let their calculator do all the work, and take it from there. Okay, so let's let our calculator do all the work. So we care about doing stuff to the nearest gallon, which is going to make our life easier. First thing that we're going to do is we're going to run to y equals and then type in that integral that we had. 25 times parentheses 1 minus e to the is second ln e to the negative 0.12t, so negative 0.12, and then x is going to be our t. Let's move to the right. Let's close the parentheses, hit graph. Now we care about the integral between 1 and 10. So let's actually do that. We can integrate on here and find, using our lower limits and our upper limits, the actual answer. So second, calc, the integral is 7. So hit 7 or go down. The lower limit, we're just going to type out 0 and hit enter because we're given that exactly. The upper limit is going to be 10, so we're going to type out 10 and hit enter on that. And it's going to give us 104.415 blah, 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 blah. We care about the nearest gallons, so 104 gallons. So what I said on the previous thing is that we're going to take our 104, add it to the fact that we already have 1,000 gallons waiting for us, and I don't really need a calculator for that even though I did it. We end up with 1,104, so let's go back and write that out. All right, so this guy ended up being 104 point something, so 104 after it's rounded, plus 1,000 is 1,104, which is going to be B, baby. Fun stuff. If f prime of x equals ln of 2x minus 1 plus the square root of 3x plus 6 plus 0.3x minus 8, where does f, the original f, have a local minimum? So this is what we're looking for. Okay, this is what we're looking for. F has a local minimum, right, if it looks something like this. Now what that means is you go from a negative slope to a positive slope. What that means, in addition, is if you have f prime, which we do, you have some type of graph that is negative, hits 0, and then becomes positive. So that's what we're going to look for. We are going to graph this guy because that's the derivative. We are going to find not only where it crosses the x-axis, but where it goes from negative to positive on the x-axis. Because if the derivative goes from negative to positive, that means the derivative goes, or the original rather, goes from a negative slope decreasing all of a sudden to a 0 slope here, to increasing, therefore has a local minimum. So let's run to our calculator, type that all in, find our 0, and see which one we get. All right. Y equals, ln is right here. We've got 2x minus 1. Close it. Then we have plus, the square root is second x squared button. Inside we're going to type out 3x plus 6. Get out of the square root. Add 0.3x. Like that, and then minus 8. All right, so what we're looking for is, since this is the derivative and we care about like critical points and stuff like that, we are looking for where this crosses the x-axis, which is going to be right around there. So we need to calculate the 0. So again, and not only that, but we care about it being a negative derivative to a positive derivative. So yeah, this is the point that we care about. So let's do second calc. Let's go to 0 by hitting 2. We're going down. My left bound, obviously I don't see anything here, so I have to make sure that I move right a few times until it starts blinking like that. Okay, hit enter, then cross the x-axis like that, hit enter again. For guess, always hit enter. And it's going to be 4.675, blah, 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 blah. So let's go back and circle the one that we need. So we got 4.675, which is going to be D. Wasn't that fun? That was fun. The graph below shows the velocity function of a particle in feet per second. Velocity function. Estimate the total distance traveled by the particle in the first 7 seconds. All right, first things first. They don't want where we're at. They want the total distance traveled. And they're asking us to estimate, but since this is a calculator section, we'll actually use our calculator to come up with the most accurate thing that we can. Now, taking the integral of the velocity gets us distance traveled. What the integral gives us is the area under the curve. So this is what I want to figure out. I want to figure out all of these areas. And I know down here is a negative area, but again, what I want is the total distance traveled. So if you think logically, like if I were to take 5 steps forward, 3 steps back, that's 8 steps total. Now 5 steps forward, 3 steps back is a displacement of 2. I don't want displacement. I want to find all of this area, all of that area, and all of that area added together. So let's see what I have. First things first is I have a triangle with a base of 1 and a height of 1. Okay, not only do I have that though, but I have another one right here and another one right here. So what I have so far is 3 triangles with a base of 1 and a height of 1. So the triangles part is going to be 3 times half times base times height. Okay, those are going to be my triangles. I also have, and we're going to go with the easy shapes first, a square with a base of 1 and a height of 1. So my square is just going to be 1 times 1. I think I can handle that without a calculator, but I'm going to use it anyway. But what I do want the calculator for is this third part. I have a quarter of a circle and a half of a circle. So in all, I have I have 3 quarters of a circle. My circle has a radius of 1, so pi r squared, so 3 quarters pi 1 squared. Okay, so this is how I'm going to handle this problem. I'm going to type all of this into my calculator. Okay, even though it is an estimate, and maybe I don't need to, but I'm still going to type it into my calculator to get the most accurate result that I can. All right, so we've got ourselves 3 triangles, so 3 times 1/2 times 1 times 1 plus 1 square, so 1 times 1. And then we've got our 3 quarters of a circle, so 0.75 times pi times 1 squared, even though it seems redundant. We're doing it anyway. And we'll get 4.85, so that rounds up nicely to 5-ish, so we'll go back and make it 5-ish. And since I got somewhere in the 5-ish range, the answer is going to be 5. And that's how you do it. For -1 to 1, let f be a function with the first derivative given by f prime equals e to the 3x to the 4th minus 2x minus 6. Which of the following intervals corresponds to where the graph of f is concave down? Well, we have f, right? And we have f prime. F prime is going to give us some equation. Now, f is going to be concave down when the second derivative is negative. Now, if I give you the graph of the first derivative, okay, and let's just make believe it looks like that. If I were to graph the first derivative, the second derivative, meaning negative, means where my line is decreasing. Wherever the derivative is decreasing is going to tell me where the second derivative is negative. So what I need to do is I need to find the minimum, okay, of where it goes from decreasing, where the derivative goes from decreasing to increasing. Okay, negative slope of the derivative means that the second derivative is negative. So I'm going to run to my calculator, type that guy in, hopefully get a picture that looks something similar to this, and find out my minimum. Once I find my minimum, I can find out where my graph is concave down. So let's do that. All right, so let's graph the derivative. That was e to the stuff. So e to the stuff is second ln. That stuff is 3x to the 4th minus 2x. So 3x to the 4th. Let's scooch out of there. Minus 2x. Get out of there. And then minus 6. And since we care about stuff happening in between -1 and 1, let's just change our window to where the x minimum is -1 and the y minimum is 1. Graph. All right. So what we care about is where this is the derivative. So if we care about concave down, we care about where the second derivative is negative. In other words, if the second derivative is negative, that's implying that the slope is decreasing. So we need negative slopes. So the way to do that is to find the minimum, which is going to be right around there. Once we find the minimum, we can find out when this guy stops decreasing. So let's go to second, calc. Okay, let's do minimum, which is going to be 3. The minimum is right around here, so we can hit enter right away and then just move to the right of it. Yep, I did that. Move to the right of it, and here we have, it starts to increase right there. Hit enter, and our minimum seems to happen at 0.550. So what's going to happen is our graph is going to be, our original graph is going to be concave down all the way up until 0.550. So let's go back and say that. And I ended up with this guy, D, because it goes all the way from -1 to 0.550. So the answer is going to be D. That is when the original function is concave down. The graphs of a of x, b of x, and c of x are shown below. Which equation could represent f prime of x, the derivative of f of x with a local minimum when x is less than 0, or x is less than 0 implies this. If all of these could potentially be derivatives, then what we're looking for is when f of x, if it's a local minimum means that the original graph looks like this, which means its derivative goes from, the slope is negative, so the derivative goes from negative to positive. Okay, in other words, the derivative is going to cross the x-axis starting below it and then going above it. So we need something that looks like this. Okay, since these are all going to represent the derivative, I need something that looks like that. Also, I only care about it happening when x is less than 0, so none of this matters. So it looks like the only graph that does that is this red one, and of course I covered it with my pen. The red one is A. So A is the only one that seems to go through my x-axis on the left side of this axis, and it goes from negative to positive. So we're going to stick with A only. B would represent a local maximum, and C, which is the green one, or wait, no, the green one is B, so the green one doesn't even count. C is a maximum. So yeah, we're only sticking with A. A is going to be our guy, that's it. No calculator needed. If the derivative of f of x is positive for all real numbers x, and the integral between 2 and 9 of f of d dt is 0, which of the following tables of values could represent f of x? All right, so we're looking at two things here. The derivative is positive, which means it's strictly increasing. If the derivative is positive, that means a positive slope throughout. So I need my values to always increase, which means you're decreasing, so you're not an option. B is an option. C is an option because you're increasing. You're decreasing, and you decrease then increase, so those guys are no good. Now what this is saying is between 2 and 9 I have 0. So I don't know what the graph looks like. But if something is going to be 0, that means if you're 2 and you're 9, something like this has to happen where the graph below the x-axis and the graph above the x-axis has areas that cancel each other out, which means I need negative values down here and positive values up here, right? So I need to have negative to positive, and B is the only one that does that. C would give us an area that is only going to be negative because it starts out negative, it ends negative. So C is going to look something like this, where maybe you have this, you have that, right? And it goes like that, which means negative area only. Whereas this has the potential of it is going to cross the x-axis and has the potential of equaling area over area, and then therefore giving you a total area of 0. So that's how you do this problem. Very bizarre, no calculator necessary, you just got to do it. The graph below shows the second derivative, f double prime of x, of the function f of x. On which interval or intervals is the graph of f of x concave up? Well, this is a calculator problem that doesn't need a calculator. If it's concave up, that means the second derivative is going to be positive. And if this is the graph of the second derivative, we care about where the second derivative is positive. In other words, everything above the x-axis, which happens between here and happens from here on forever. All right, so we have a positive second derivative between -1 and 0, and also from 4 on. Now we're not going to include those numbers because it's 0 at those numbers. So we're going with parentheses here, and that seems to match up with D. So yeah, this is a pretty basic problem, nothing to overthink. You just have to understand what, concavity means when it comes to the second derivative. No calculator needed. A 20-foot ladder is leaning against the wall. The base of a ladder is sliding away from the wall at a rate of 2 feet per second. How fast is the top of the ladder sliding down the wall when the base of the ladder is 12 feet away from the wall? All right, so this is a related rates problem, and this is a calculator problem, but I'm not convinced we're going to need the calculator. Maybe we will, maybe we won't. Let's draw a picture and let's draw what we know. Okay, that is an awful triangle, but leave me alone. This is the wall. I'll call it W. This is the base, I'll call that B, and this would be the ladder leaning up against it. We'll call it L. Okay, what I know is that the ladder is definitely 20 no matter what. I know that this is a right triangle. Okay, what I also know is at the moment the base of the ladder is 12 feet away from the wall. So this is always going to be changing, but at this very moment we have 12. What I don't know then is at the very moment, where is the ladder leaning up against the wall? So what we need to do is we need to find out that W, and we're going to use Pythagorean theorem to do it. 12 squared plus W squared equals 20 squared. 12 squared is 144 plus W squared equals 400. Subtract 144 from both sides. That gets us W squared equals 256. Square root both sides. You don't need to positive or negative anything because this is going to be distance. And the width at that moment is going to be 16. So you're 16. Now, in order to do the related rates problem, we need to realize what is changing and what's not changing. We're going to reuse this equation, but not do too much. The ladder is always going to stay 20. Okay, where my base is and where it changes versus where the wall is and where that changes is always changing. So the related rates problem that I'm going to write out is going to be the base squared plus W squared is going to equal 20 squared. Okay, now what we're going to do is we're going to ddt both sides. Take the derivative with respect to time. So ddt, ddt. That leaves us with the derivative of b squared, which is 2b, with respect to t is db dt, plus the derivative of w squared is going to be 2w dw dt. That's going to equal 0, because the derivative of a number is 0. Okay? So let's plug in what I know and what I don't know. I now know that b is 12, so 2 times 12. db dt is the top of the ladder sliding on the wall, the base of the ladder is 12, because the base of the ladder is, no, it's not, it's, what is it? It's sliding away from the wall at 2 feet per second. So db dt is 2, because it's 2 feet per second. Okay, that's going to be plus 2 times w, which is 16. dw dt is what I'm trying to find. That's going to equal 0. So let's write this all up here. 2 times 12 times 2 is 4 times 12, which is 48. Plus 2 times 16 is 32. dw dt equals 0. Let's subtract 48. Let's subtract 48. 32 dw dt is going to be negative 48. Divide both sides by 32. Divide both sides by 32 is dw dt equals negative 1.5. Why negative? Because it's sliding downward. So negative 1.5 is going to match up with 1.5. And that's how you do that problem. No calculator needed. You could have used a calculator, I guess, but not needed. A particle moves along a line so that its acceleration for any positive time t is given by a of t equals, holy crap, ln of 2.1 t plus 1.2 plus 1.43 times the square root of 0.021 t minus 0.18. If the particle's velocity at time t equals 0 is 4, what is the velocity of the particle at time t equals 8? All right, so we're given an acceleration function. We're talking about velocity. So in order to turn acceleration into velocity, we need to integrate the acceleration. Okay, we're going to do that from 0 to 8. This will give us the total velocity from 0 to 8. On top of that, we're going to add 4 because the velocity is already 4. So what I need to do is I need to run to my calculator, type that guy in, find the integral from 0 to 8, and add 4 to it. All right, so let's go to that y equals and start typing stuff in. ln of 2.1, t is x, okay, x is t, plus 1.2, close the parentheses, plus 1.43 times the square root of 0.021t, which is x. Let's get out of there. Minus 0.18. All right. Let's hit graph. Not so bad. But what I have to do is I have to integrate from 0 to 8. So let's second calc. 7 is my integral. Lower limit is 0. Upper limit is 8. So you hit your number, you hit 8. This guy gives me 10, I'm sorry, not 10, but 18.356. So if we were to take that guy, 18.356, and add 4 to it, we'd get 22.356. So let's go back and make that happen. And so we ended up with 18.356-ish plus 4 is 22.356-ish, which looks to be C. Gross. Which of the following must be true? All right, so let's do this. Okay, let's kind of treat this as if it's u substitution. Let's let u equal 3x. So du dx is going to be 3, and after flip-flopping the 3 and the dx, we get du over 3 equals dx. So now that guy can be written as the integral from 5 to 10 of f of u, oh, be careful, du over 3. So let's rip out the 1/3. 1/3 from 5 to 10, f of u du. Okay. Now, what happens is basically we're going to take the derivative of some f of u, and that's going to give us this right here. We have the integral from 5 to 10 of f of t. Okay, and remember, since this equals 15, right, I can multiply everything by 3, multiply both sides by 3, and that's going to get us 45. The limits don't change. They're still 5 and 10. And yeah, so kind of a very, very, very bizarre problem. Where am I? F of t dt equals 45. Oh, between 5 and 10. Yeah, kind of a very strange problem. Not a huge fan of it, but yeah, that's how you would do it in this case. Let f be a polynomial function with values of f prime of x as selected values of x given in the table below. Which of the following must be true for -3 to 6 for our x values? So we have -3 to 6. We have a bunch of coordinates given to us. All right, now this is f prime of x. Okay, and we want to talk about facts of f prime of x. So what we know is the derivative gives us slope. All right, negative derivative is going to be decreasing function. Positive derivative is going to be an increasing function. So let's kind of go through all of this stuff and see what we have here. All right, now the first one asks if the graph of f is concave up. Now, if you might remember from AP Pre-Calculus, concavity has to do with the increase or decrease of its rate of change. I'm going from 4 to 0 to 2 to 6 to 3. Something is going to be concave up if the rate of change is increasing, and my rate of change is not increasing. In fact, I start out by decreasing. So since my rate of change is not increasing, this guy is not concave up. The graph of f has at least 2 points of inflection. All right. Well, looking at what I have, it looks like f prime changes direction twice. Right? Because I go from 4 to 0 to 2, so that's a change of direction. And then from 2 to 6 to 3, there's another change of direction. So since it changes direction twice, we can assume that the graph has 2 points of inflection. Now let's rule out the others. F is always increasing. That's false because f prime of 1 is 0. Which means if it's always increasing, if f prime of 1 is 0, this means we have a 0 slope right there, which means not always increasing, so C won't work. F has no critical points. Well, that's not true because there's one right there. And so you're not right. F has at least 2 relative extrema. No, because it's always increasing except for at one spot. So we can't determine if there's more than one relative extrema. So B's got to be it. So this is a calculator section that didn't require a calculator. It just kind of required a little bit of knowledge about the derivative and how we can use that derivative to our advantage. The region R is bounded by the equations y equals log of x plus 1 plus 2 and y equals x squared in the first quadrant. I don't know where the rest of the word quadrant is, but it's gone. What is the volume of the solid form when the region R is rotated around the x-axis? So, all right, logs usually look like this, right? X squared usually looks like this. So you're going to be my A, you're going to be my B. I'm rotating you around the x-axis, right? So this is the washer's method. So what we're going to do is, since my log is the one that's probably up here, you're going to be my log and you're going to be my x squared. So the equation or the integral that I'm going to set up, okay, is going to have pi living out front. I need to find my lower limit. I need to find my upper limit. And then what I'm going to do is I'm going to take log of x plus 1 plus 2, square that, and then I'm going to subtract out x squared squared. Okay, dx. So again, I'm going to graph these guys. I'm going to find out where they intersect. Once I find out where they intersect, I'm going to write those numbers down, and then I'm going to use this guy right here, the integral, and I'm going to plug all of that stuff in. I'm going to have to make sure that I include pi on the inside when I do the integral so I don't make a mistake. But I'm going to integrate that using my calculator, see what number I get, and we'll find out what happens. So let's start graphing away. We've got log of x plus 1 plus 2. So there's my x, there's my plus 1, close it, plus 2. And then my other guy was x squared. Now I need to find out where these guys intersect in the first quadrant. Now this is good news. Let's zoom in. This is good news because these guys intersect over here, which means my left limit is going to be 0. So my left limit is going to be 0 based on the fact that my first point of intersection is over here in a different quadrant. So I'm going to use 0 as my lower limit. And so all I have to do is find out my upper limit. So hit second calc. Let's find out where these two guys intersect. So let's move over here a little bit. Hit enter. Let's move over here a little bit. Hit enter. Hit enter again. And I get 1.5513. All right, so let's set up our integral. Let's go back here. I don't need this anymore. Clear, clear. Now, I'm going to throw pi in front of everything. Pi. Okay. And then I have parentheses, parentheses, log of x plus 1, close it, plus 2, close it, square it. and then minus x squared, close it, square it, and then close it one more time. All right, so now that I have what I need, I think everything is typed out correctly. I don't think I have any errors. I can hit graph. All right, that looks pretty good to me. Let's hit second calc and hit 7. Type in my lower limit, which was 0, my upper limit, which was 1.551. Hit enter, and I get 18.757 blah 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 blah. Whew. So let's go back and type that out. All right, so we ended up with 18.757, which is B. And that's going to do it for the calculator section. So on to some open-endeds. Fun, fun, fun. All right, boys and girls, let's take a look at our first free response question. It's a calculator problem. We're given a table of values and a good old particle problem. So a particle moves along a straight line, and its velocity in inches per second at various times in seconds is given by this table below. So the table on the left, not really consistent on what it goes up by. It goes up by 2, goes up by 3, goes up by 3, goes up by 2. Over here, we're just given a bunch of ugly numbers, which is why it is a calculator problem. And so, here we are. We'll do A and B, and then C and D. We'll go back and forth between here and the calculator. But let's get started. Estimate V prime of 9. Now, V prime of 9 means if you were to take the derivative and plug in 9, what do you get? Now, this is the regular old function, and there is no 9. So what I'm thinking is, okay, the derivative. Oh, so the derivative means slope. So if I'm going to estimate V prime of 9, why don't I estimate the slope between 8 and 10? Because 9 just so happens to be in the middle of that. So what we're going to do for part A is we're going to do V prime of 9 is going to be the slope formula connecting 8 and 10. So we'll do V of 10 minus V of 8, vegetable juice, over 10 minus 8. So we'll run to our calculator and find out what V of 10, let me see, V of 10 is 12.100 minus V of 8, which is 7.744 over 10 minus 8. We'll just throw all of that into a calculator, get some number, and we'll see what happens when we do just that. All right, let's plug stuff in. Big parentheses for the numerator, 12.100, which is just 12.1. Minus 7.744, so 7.744, close the parentheses, all divided by 10 minus 8. It's going to be 2, but we're just going to use our calculator anyway for just, showing you how to do stuff purposes. Hit enter, and you get, a nice 2.178, nothing to really round. So let's go back, write that out, and explain what that means in this context. Okay, so we ended up getting 2.178. Now, if we're given a particle moving at inches per second over time, right, the derivative of that is going to be inches per second squared. So the answer for A is going to be inches per second squared. Okay, and that's because it's the acceleration. When you take the derivative of the velocity, you're going to get acceleration. That's why we get the per second squared attachment. Now that's A. B is asking us to describe what the integral of V prime of t from 0 to 10 represents. The integral, right, between 0 and 10 of V prime of t. So I guess we'll do dt. Now what that gives us normally is we would say, okay, so that would just be like the capital V of 10 minus the capital V. But what that means here is if we're taking the integral of the derivative, we kind of go back to square one, which in this case is regular V of t. So this is going to end up being V of 10 minus V of 0. Right? And I don't need a calculator for this one. We already know v of 10 is 12.100, v of 0 is 0, and because I kind of can do the math in my head, I know I'm going to get 12.100. And since this is dealing with the original velocity, it's going to be inches per second. Okay? So the answer to A was acceleration. The answer to B was take the acceleration, integrate that, which takes you back to the original velocity. Fun, fun, fun in the sun. Now what we're going to do is we'll open up a new slide, okay? And we'll take a look at C and D on this slide and try to understand what they mean and see if we need our calculator for that. So C is asking us to use Riemann sums. Ooh, everybody loves that, with 4 subintervals to estimate the total distance traveled by the particle in the first 10 seconds. Left Riemann sums. Ugh. Okay, so the way you handle left Riemann sums is we're going to have 4 subintervals. Here we see like 5 chunks, which is kind of what we want because 4 subintervals means u to u, u to u, u to u, and u to u. So what we do is we take the length of the chunks, right? And we use this number because it's considered the left subinterval, right? We could draw ourselves a line, and I don't know what this picture is going to look like, so I'm not going to really lose a whole lot of sleep over it. But again, when you're using left Riemann sums, you're going to use whatever intervals you have and plug in the lower version of that. If it was the right Riemann sum, we plug in the upper version of it, and if it was, mid-point Riemann sums, then we would just do, the middle. That's not what we're dealing with here. So this interval is 2 minus 0, so we're doing problem C here. 2 minus 0, which is 2 units in length, and we're going to multiply the left side of it, which is going to be 0, plus the second interval is 5 minus 2, which is 3 units in length, and we're going to multiply the left side of it, which is 0.484. So we will want our calculator for this guy. The next interval is going to be 8 minus 5 units in length, so plus 3 parentheses. And we're going to multiply the left of it, so 3.025. And then the next one is 2 units in length. And we're going to multiply the left side of that, 7.744. So let's run to our calculator and see what happens when we type all of that in. Okay, 2 times 0, probably don't need to use that, but I did it anyway. The next one was 3 times 484, so 0.484, easy to memorize, that's a Pottstown area code from where I'm from, plus 3 times parentheses 3.025, and then the next one was 2 parentheses 7.744. It's going to be an underestimate. Oh, ooh, that was a close one. 7.744. Okay. Looks like no mistakes made. Thank goodness. 26.015. So let's go back, write that out, and try to explain what that means. All right, so the number we ended up with, 26.015, and since we're integrating the velocity function, the integral of the velocity function is the position function. So according to this, what this is telling us is we traveled a distance of 26.015 inches. Now, is that realistic? Is that really what's going to happen? No, because if we're using left Riemann sums, then we're probably underestimating our actual answer, but that's what we were asked to do here, and so that's what we did. Now D is asking us to use quadratic regression to find the equation of V of t. So we're going to take this table right here. We're going to do quad reg in our TI-84 plus, and that will get us a formula. Once we get the formula, use the equation to find the actual distance traveled by the particle over the first 10 seconds. Show all the steps necessary. So not only are we writing out a formula, we're going to use that formula to find the actual distance traveled over the first 10 seconds. So here we go. Okay, this is how we do quadratic regression. So we're going to take the table, okay, and we're going to use all the numbers in the table. Go to Stat, go to Edit, And on the left side, type out the x, or in our case, the t values. So that was the left side of the table, 0, 2, 5, 8, 10. Okay? So let's move to the right, and we'll put in those numbers, which was 0 again, 0.484, 3.025, 7 that's a 1, 7.744, and 12.100, which is just going to be 12.1. So in this problem, right, if you remember, we were not just said, let's find the equation. We were asked to find the equation and then use that equation to do something else. Okay, so when we find, quad reg, this is what we're going to do. Go to stat, go to calc, and quad reg is number 5. So you can either hit 5 or go down to it. Great. Now, since we're not only going to write out this formula, we're also going to use this formula. We're going to store this in our calculator, so when we use the formula, it's going to be there waiting for us. So store reg EQ, hit enter. Oh, nope, I'm sorry. Go to vars, yvars, enter, enter. Okay, go to vars, yvars, enter, enter. And this will store our equation into y equals. Go down to calculate, hit enter, and there's our equation. It's actually really pleasant. And what we'll do is we'll hold on to it, we'll save it, and then we'll write it down so we don't have to go back and then come back and then go back and then come back. So the equation in this case is just going to be y equals 0.121x squared. That's it. Now, here it is waiting for us when we hit y equals. Now, is it exact? No, because TI likes to always make it different. But part 2 of this was asking for us to find the distance traveled for the first 10 seconds. So we're going to use our calculator to do this. Now, this is our velocity function. This is the velocity answer that we got. So in order to find the total distance traveled for the first 10 seconds, we're going to integrate. So we do that by using our calculator and hitting second trace, which takes us to calc. 7 is the integral. So go down to 7, you get a nice little parabola, which makes sense, and we're going to set our lower limit. Since we're doing the first 10 seconds, our lower limit will be between 0, and our upper limit will be 10, and that's going to give us an answer of 40.333333333333. So let's go back, let's write down all the information that we came up with and try to explain what all of that means. All right, so let's finish this guy out. All right, we're on D, and the equation that we ended up with was, if we're doing the velocity function, quad reg gave us v of t equals 0.121 t squared plus 0t plus 0. So this is part 1 of that problem. Okay, that's the equation that we came up with. Now, in order to use that to find the actual distance traveled using our calculator, we decided that we would integrate that velocity function, which gives us distance. So between 0 and 10 of the velocity function, dt, ended up giving us 40.33333, which means we actually traveled a distance of 40.3 repeating inches. Now, what we had up here was a complete underestimate, which usually happens, not always, but usually happens with left ream in some intervals, because you're not looking for perfection, you're looking for drawing rectangles and blah, 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 blah. But this is the actual distance traveled according to this information. And this is the underestimate. So yeah, that's part 1, or problem 1 of our free response question here in the ultimate GOAT, whatever I'm calling this thing. So more to come. 4 of them, 5 of them. Ugh. Thanks for watching, like, and subscribe. Okay, free response question numero dos. We have ourselves calculator stuff, and as you can see from here, and if you're looking ahead, you're going to be like, yeah, I'm going to need a calculator for this one. You are. Let R be the region bounded by the first quadrant. So let's kind of draw ourselves a picture, because I know what's going to happen, especially since I created this problem. The curves f of x, also the first quadrant, the curves f of x equals 1 over 21, x squared plus 1, and g of x equals e to the 6 minus x minus 1, and to the x-axis. I don't know why it's and to the x-axis has to be thrown in there if it's the first quadrant. Thank you, but no thank you, ChatGPT. Now, f of x is going to be this little parabola, this very wide parabola, and what we will see when we throw this into the calculator, f of x is going to look like this, give or take. Perfect? No. Accurate enough to get by? Mm-hmm. And what we will find about e to the 6 minus x minus 1 is it's going to look something like this. Okay, again, perfect? No. Accurate enough? Yeah. So A is asking us to find the area of region R, of course, being the combination of these two guys, this shaded region, if I were to shade that black, which I will not do. All right, so what we need to do is we need to find the area of region R, and we're going to show all of our work. There's two things that I have to do before I throw this into my calculator, and I'm going to write it all out. Okay, I'm going to write it all out. What I want to do is the area under the curve is found by taking the integral, right? So if I were given just one function, if I were told everything happens between 0 and 8, I would take the integral between 0 and 8. Easy peasy. But it's not that easy peasy because I have two curves that run into each other. Okay, so issue number one is if I wanted to find this area, I'm splitting this into two parts. And this is how I'm going to handle all three of these problems. The intersection of the blue and the red here I'm going to call A for now. Okay, for now. Now, what's going to happen here is if I wanted to find just the area under this blue curve, I would take the integral from 0 to whatever that A is, and that blue curve is f of x dx. That gives me this information right here, that area. Now, that's not all I want because I also need this chunk right here. That's going to be the integral from A to this guy, which we will call B. Now, everything is being held in the first quadrant, which means the moment it crosses the x-axis is when I'm done. Okay, B is going to be found by finding the 0 of g of x. So once I find A, which will be found by, intersections, and once I find B, that gets me this chunk right here when I integrate it. If I add this chunk and that chunk, I get all of R, and that gets me the answer to A. So what I'm going to do is I'm going to run to my calculator. I need to find A. I need to find B. Once I find those, I'm going to integrate them in my calculator, and I'm going to add those guys up and see what happens. So we're going to do all of this all at once. All right, so let's plug in both of those formulas. I'm going to let f of x be y sub 1, and that was 1 over 21, which I'm going to put in parentheses because I'm paranoid. Okay, x squared, and then plus 1. Okay, y sub 2 is going to be my g of x. That was e to the x, so second ln, e to the 6 minus x. So let's throw all of that in there, 6 minus x, and then go out of here, and let's minus 1 because that was the other part of it. All right, let's see what this graph looks like. Okay, so there's the picture that I drew, but a little bit flatter maybe, I guess. So my thing number one is I need to find out what that A was. Okay, what that A was. Now, I do that by finding the intersection of the blue and the red. So I'm going to hit second, calc, intersect. So hit 5. Let's move closer to the intersections. For the first curve, I like to always hang to just to the left of it. Hit enter. For the second curve, just to the right of the intersection, hit enter. Always guess, hit enter again. And we are going to pocket the fact that our intersection is going to be 4.861. We're going to use that number over and over and over again. Okay, so A is 4.861. I still have to find B. Okay, now B is going to be the 0 of the red line. If I want to focus on just one of the lines, what I'm going to do is I'm going to go to y sub 1 and go to the equal sign and hit enter, so that all I see is the red line. So I'm going to find the 0 of the red line here by going to second, trace to calc, 0. Okay, so let's move to the right a bunch of times so I can see my little cursor. Come on, 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 there you are. Let's go to the left of the 0, hit enter. Let's go to the right of the 0, hit enter. and hit enter. And just like that, the 0 is 6. So my two key numbers are going to be 4.861 and 6. So now using that A as 4.861 and that 6 as B, we can do what we set out to do. So Y sub 1 is going to be my f of x. Let's focus on that, and so we'll highlight the equal sign for just that. Okay? So let's graph so we can see just the blue line. Hooray, hooray, hooray. Now if I want to integrate this between 0 and 4.861, I'm going to hit second, trace, which takes me to calc, and there's my integral function. So lower limit is 0. Hit enter. Upper limit is 4.861. Hit enter, and it fills it in for you. And what we get is 6.684. Okay, so we're going to write that out. We're going to, when we go back to the main slide area, we'll write all of this stuff out. But this is how you find the first chunk, the blue chunk. Now to find the red chunk, we're going to go back to y equals, pretend that blue doesn't exist by hitting enter on the equal sign, and by hitting enter on the equal sign for red, now we only see red. So if we hit graph, there you have it. We care about the integral between 4.861 and 6, so we're going to do the same exact thing with our new limits. Second, calc, 7, 4.861, enter, to 6, enter, and we get 0.985 when rounded. So we're going to take those two numbers that we just got, 6.684 and 0.985, and we're going to add those guys together, and that's going to give us what we need. All right, so we ended up with two pretty important numbers, okay? That A ended up being 4.861. That B ended up being 6. So rewriting this guy out was 0 to 4.861 f of x dx plus 4.861 to 6 of g of x dx. Okay, this guy gave us 6.684 plus this guy gave us 0.985. And dummy me, I forgot to show this part in the video. I don't know why I did that, but when you add these guys together, I think you don't need my help on how to add things in a TI-84 Plus. If you could do all of this stuff in a TI-84 Plus, I think you're good. So dumb move by me, but you get the idea. That's what we're going to get here if we were going to go back to our TI-84 Plus and add those up. So that's part A. Part A, dunzo funzo. Now, B is asking us to find the volume of the solid formed when the region R is rotated around the x-axis. So you spin this around, you're going to get some weird looking, I don't know, like the top of a hat thing. I can't draw these, so I'm not even going to try. But what we're going to do is we're going to use the same idea. Generally speaking, when you want to rotate a line around the x-axis to make a solid, the general formula for that is basically you take, and this is any line, so I'm not going to use F and G, I'll use R. So you would do pi times R of x dx, and you're going to use your limits. Now what I'm going to do is I'm going to set this up the same exact way, using these two guys being added to each other, but what I'm going to do is I'm going to square the functions, I forgot to say that over here, square the functions and attach pi to it, okay? So I'm going to write out from 0 to what I know now is 4.861. I'm going to put pi in front of it. I'm going to put f of x squared dx. And then I'm going to add from 4.861 to 6 pi g of x squared dx. So I'm going to run back to my calculator, I'm going to do all that fun stuff, and I'm going to see what happens. All right, so unfortunately going back and forth and doing all this stuff makes everything go away in my calculator, but no big deal. According to what I wrote out, let's do this. Let's make believe that I already have this stuff written there. So the original functions were, I believe I had it as 1 in parentheses, 1 divided by 21, and then you have x squared plus 1, and then the other one was e to the 6 minus x, right? Yeah. And then minus 1. Okay, so the reason why I'm rewriting it out like its original form is I want to show you how we can manipulate it so that it's not so bad and I don't have to clear everything and rewrite everything. So if I wanted to make these pi functions squared, I'm going to go to second, insert. I'm going to hit pi. So here's my pi. No. Didn't I do that? Second, insert. Hold on, let me go back. Let me delete it. I must have done something stupid. Second, delete, which makes me insert. I'm going to hit oh, I know what I did. Second arrow, which is pi, and I'm going to add another parentheses there. I'm going to go all the way over here and close the parentheses and then make that squared. Okay, so now it's exactly what I want it to be. So without me making any typos, let's try that again. Second, insert, second, caret, puts the pi there, parentheses, go all the way to the right, close it, square it. And now I'm going to do exactly what I just did before. Okay, so let's hit the graph, see what they both look like on the same thing. All right, it's definitely new, but that's okay. It's supposed to be. Let's focus on f of x first by eliminating, or not eliminating, but just, silencing the red. So now if I hit graph, I only see that. And we're going to integrate between 0 and that 4.861 number. So second, calc, integral, which is 7, lower limit is 0, upper limit is 4.861, and with that we end up getting the number 38.594. So let's hold on to that, 48.594. The second one, let's go to y equals. Let's highlight u so I don't see you anymore. Let's highlight u so I do see you now. Let's hit graph to make sure there she is. Let's integrate that by hitting second, trace, which takes me to calc. Go to 7. I care about all the stuff between that 4.861 and 6. And it gives me a value there of 3.9907, which is 3.991. Now what I forgot to do last time is let's add those guys up. Okay, 38.594 plus 3.991, 3.991, enter, and you get 42.585. All right, so let's go back and write that out. Okay, so u ended up being that 38.594. U ended up being 3.991. We added them together and got 42.585. All right, so that is how you do B. Now C is extremely similar to B. C is saying instead of rotating it around the x-axis, rotate it around the line y equals -2, which is this line way down here. This requires the washer method. And generally speaking, what you do with the washer method is you would integrate, right? And I'll write it down here. You would integrate from A to B. You would still do whatever function that you have, right? You would still have pi out there. But then what you would do is you would take whatever your curve is, minus whatever number, okay, whatever number that y equals is, and then square it dx. So what that's going to look like here, is I'm going to have an integral from 0 to 4.861 of pi f of x minus -2 or plus 2. dx. Okay, and I'm going to add that to the integral from 4.861 to 6 of pi g of x minus negative 2 or plus 2 dx. Squared, squared. Can't forget to square those parentheses. That changes everything. Okay, so let's run to our calculator, see what happens. Okay, so coming back here and going back to the y equals that we had before, when we manipulated them, we're adding 2 inside each of the parentheses. So I'm not going to write out plus 1 plus 2 because that's a waste of time. Let's just make u plus 3. And instead of down here doing the same thing and writing out negative 1 plus 2, let's just make that plus 1 because negative 1 plus 2 is plus 1. So let's focus on just the blue. We're going to do the same exact steps that we did before. Focus on just the blue. Second trace takes us to calc. 7 is going to take us to our integral. I don't see anything, but who cares? I don't need to see anything. If I'm adding 2 squared, which is plus 4, it just moves everything up. So I'm going to plus, or my lower limit is 0. My upper limit is that same 4.861. If that number isn't burned in your memory after watching these videos, shame on you. We end up by doing that getting 175.675. Okay, so that's the first guy. The second guy, let's go back here. Let's hit enter so I don't see it anymore. Let's hit enter so I do see u. There u is. And let's do the same thing. Second trace 7. I care about 4.861 to 6. That value is going to be 30.677. Now let's add those two numbers up. Okay, 175.674 plus 675. Why did I say 4? Plus 30.677. And we get 206.352. Let's go back and circle that. Doo-doo-doot, says the computer. Let's go back, circle that, and be done. Thank God. All right, so this top guy ended up being 175.675. This guy ended up being 30.677. And when we added them together, we got 206.352. Yum, 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 yummy, yum, yum. I don't need that over there. That's in the way. All right, that was intense. So hopefully you enjoyed it because I certainly did. All right, more to come. Free response question number 3. No calculator. That's fine. We don't need one. Calculators are for suckers. Anyway, this figure below right here shows the velocity v, also known as dSdt, also known as f of t, all these names, of a body moving along a coordinate line in meters per second. Answer the following questions based on the graph. Well, let me reiterate that this graph is velocity, not position, which is usually given to you as s of t. This is the velocity function. So anything that's positive is u moving forward. Anything that's negative is u moving backwards. So at this moment right here, you're moving forward at meters per second, 1 meter per second. Now you're moving forward at 3 meters per second. Now you're moving forward at 3.5 meters per second. Now here you're moving backwards at 3 meters per second. So when does the body reverse direction? Well, the body reverses direction at any time where it crosses the x-axis. Anytime there's a sign change is when it reverses direction. So to answer part A, there's a sign change at 4 and a sign change at 8. So A is going to be t equals 4 seconds and t equals 8 seconds. And that is because the body reverses direction anytime there is a sign change. And that occurs anytime there is a sign change. And that occurs when, you can see that I'm not really good at all multitasking. That occurs whenever you cross the x-axis. Now part B is asking, at what time or times is the body moving at a constant speed? Well, again, velocity is basically positive or negative speed. So when do we have a horizontal line for velocity? Well, that happens at once. By the way, the devil is going to tell you, oh, that's constant, isn't it? That's constant, isn't it? No, we're technically speeding up. The velocity at this moment from here to here is increasing. That's not constant. You're going from 1 meter per second to 2 meters per second to 3 meters per second, back down to 2 meters per second, blah, blah, blah. The only time where you're going to have a constant speed is in between 6 and 7. So the body is moving at a constant speed when t is in between 6 and 7 seconds. And that again is because the velocity is a horizontal line. So at this moment, we're going backwards at 3 meters per second for a whole second there. And that's it. That's the only time that happens. That only time. So that's how you answer B. All right, so I switched over to the next slide, and the question that's being asked is the same thing. Same exact picture, just, cleaned everything up here. What is the body's maximum speed? Provide the explanation for your answer. Well, the body's maximum speed is actually 2 times here. Now, velocity can be positive or negative, right? A positive velocity means you're moving forward. A negative velocity means you're moving backwards. Speed is the absolute value of velocity. So this is going to happen twice. So for C, you have at t equals 2, and when t is in between, what is that, 6 and 7? We did that before. The speed is 3 meters per second. Okay, and again, the explanation for that is because speed is the absolute value of velocity. Now, if it asks you the question, what is the maximum velocity? The answer would be 3. What is the minimum velocity? The answer would be -3. But that's not what it's asking. It's asking for speed, which is the absolute value of velocity. Now, this last one has the potential for a lot of confusion. Okay, so let's try to understand one more time that this is the velocity function and what velocity means. The question being asked is, during what time intervals is the body slowing down? Provide an explanation for your answer. This is velocity. Okay, anything that's above the x-axis means you're moving forward. Not increasing, not decreasing. It means you're moving forward. I am moving forward here, 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 and here. I'm moving forward here. Okay, anything under the x-axis means I'm moving backwards. So what this is telling me is I'm accelerating, moving forward. At this moment right here, I am slowing. So pretend that this is a car. I'm driving my car faster, moving forward, moving forward, moving forward. Now I'm still moving forward, slowing down until this moment right here. Okay. Now I'm slowing down, moving forward. This is a slow down, which is a decrease in velocity. So interval number 1, and we'll write it out this way because we haven't written it out this way yet. Interval number 1 is going to be when t is between 2 and 4. Okay, now the devil is going to tell you, well, why did you stop at 4? Shouldn't you keep going? No, because now what we're doing, right at this moment right here, By going underneath the x-axis and making our digits larger, we are actually increasing in speed moving backwards. At this moment, we're stopped. Now we're moving backwards, moving faster. This is not slowing down. This is speeding up. This is staying at the same speed. And here, what we're doing is we're slowing down while going backwards. So the other interval is going to be between 7 and 8 because we're slowing down while going backwards. So the explanation for this is for the first one, it's positive, the velocity is positive but decreasing. Okay, so velocity is positive and decreasing. And for this next one, we could say that the velocity is negative and increasing towards 0. Now what that means, one more time, what that means, one more time, is since we're moving backwards, okay, we're going from moving backwards at 3 meters per second to 2 meters per second to 1 meter per second to stop. Okay, so the velocity is negative and increasing towards 0, which means you are slowing down while going backwards. So, kind of a bizarre question. Again, not a ton of math, hardly any math at all, really. It's just understanding what graphs look like and comparing velocity to position to acceleration and all that stuff. But yeah, that's free response question number 3. Pretty short and sweet. All right, free response question number 4, no calculator. Well, we don't need one. Find the equation of the line tangent to f of x at x equals 2 in point slope form. All right, so one at a time. The tangent line at any point. We have ourselves a line. I don't know exactly what happens at x equals 2. This could be completely off, but let's just make believe it happens here, right? If that is where x equals 2, the tangent line is some line that basically creates that slope at that moment. It's a snapshot of the slope at that moment. What we want is the equation of that line. So this is what we're going to do. We're going to take the derivative of this. Okay, and then we're going to plug in what happens at 2, and that's going to give us our slope. Okay, now once we have our slope, we know that x equals 2. In order to use point slope form, which is what they want, we need a slope and we need a point. This will give us our slope. We have half a point, so the other point is to take f of 2, and that will give us our y value. Once we have our slope, and we find out what happens at f of 2, and by the way, yes, f of 2, not f prime of 2. F prime of 2 gives a slope, f of 2 gives us a point. Once we have that, we write out our point slope form, which is y minus y sub 1 equals m times the quantity x minus x sub 1. All right? So those are our 3 steps. So let's take the derivative, plug in 2, and that will give us our slope. So this is just power rule, nothing. So f prime of x is going to be the derivative of x cubed, which is 3x squared, minus the derivative of 48x, which is minus 48x, plus the derivative of 3, which is nothing. F prime of 2 is going to be 3 times 2 squared minus 48, which is going to be 3 times 4 minus 48, which is going to be 12 minus 48, which is going to be, holy crap, negative 36. So our slope is negative 36. Okay, so that's part 1. Now so point slope form, we found our slope. Now I need to find our point. Our point, we have half of it, x equals 2. I need the y value, so let's plug in 2 into this original problem. So f of 2 is going to be 2 to the third power minus 48 times 2 plus 3. So that's 8 minus 96 plus 3. And 8 minus 96 is negative 88. Negative 88 plus 3 is negative 91. No, it's not. Negative 85. What was I thinking? Negative 85. All right. So that's our point. So we have y minus y sub 1 equals m times the quantity x minus x sub 1. We have a slope at negative 36. We have a point at 2, negative 85. So if I were to label you x sub 1, y sub 1, we can put everything together. Y minus negative 85 equals negative 36, x minus 2. Cleaning this up is going to be y plus 85 equals negative 36 times the quantity x minus 2. Yuck, gross, no thank you. Now B here is asking us to determine all critical points of f of x. So let's do things one sentence at a time because there's 3 things that this guy is going to ask us to do. So B is asking us to determine all critical points. Let's get rid of this over here. I don't need that. I'm going to need the space, and I'm going to probably want a new slide for C. All right, critical points exist when your derivative equals 0. So I have my derivative. I found that out. So let's set that equal to 0. 0 is equal to 3x squared minus 48. We can factor out a 3, and that leaves us with x squared minus 16. Okay, now let me move that up here. 0 equals 3 times, oh wait a minute, I know what that is, that's difference of squares. Oh, that's much easier. So my critical points are going to exist when x is positive 4 and when x is negative 4 because those are the numbers that make those factors 0. 3, who cares? So those are my critical points. Identify the intervals where f of x is increasing and decreasing. Well, this is going to be pretty easy. The graph here is a positive leading coefficient cubic, which means it's going to look like this, right? I call this the Drake cubic because it starts from the bottom and now it's here. I know Drake's kind of a sensitive topic lately, but you know what? I'm leaving it. Anyway, if I write out a sine graph, knowing very well that my critical points are 4 and negative 4, okay, I'm going to have a sine graph at negative 4 here and positive 4 here. And this is the sine graph for the derivative, which is going to be f prime. Now, what the critical points give us is where the slope equals 0. When I say, let's take the derivative and set it equal to 0, that's me finding when this slope is 0. So you are a critical point and you exist at negative 4. You are a critical point and you exist at positive 4. Which means if your critical points, anything that is not a critical point is either going to be increasing or decreasing. So here you are increasing, you hit a maximum, then here you are decreasing, you hit a minimum, and here you are increasing forever and ever and ever. So the intervals where f of x is increasing is going to be 2 of them. Okay, the increase exists from negative infinity to negative 4 union 4 to infinity. That's where we're increasing. My decreasing is only once, and that happens from negative 4 to 4. So still not done the problem yet, because now I need to classify all local extrema. So what I'm going to do is not only am I going to just say, oh, okay, well, local extrema is we have a maximum at negative 4 and a minimum at 4. I'm going to find out what those points are. So my maximum exists at negative 4. So that means we're going to plug in negative 4 into the original function to get us the exact point where this happens. So that's going to happen at negative 4 cubed minus 48 times negative 4 plus 3. So negative 4 cubed is negative 64. Minus 48 times negative 4 is going to be 192 plus 3. So 192 plus 3 is 195. 195 minus 64 is going to be 131. Okay, so that tells us that we have a maximum at negative 4, 131. And that, let's be specific, that is a local max. You know what they call it? They prefer relative in calculus. So you have a relative maximum at that point right there. Okay, circling all of the answers that I came up with so far. All right, so I have a relative maximum at negative 4, 131. To find my minimum, I'm going to do the same thing but plug in regular 4. So f of regular 4 is going to be regular 4 cubed minus 48 times 4 plus 3. So that's 64 minus 192 plus 3, which ends up being negative 125. So that's my relative minimum exists at the point 4, negative 125. All right, so we conquered all the beasts of Part B. Okay, Part B, determine the critical points, there you is. Identify the intervals where f of x is increasing or decreasing, there you is. Classify the local extrema, also known as relative extrema, there you is, there you is, there you all is. All right, now Part C, and we're going to move to a different slide in this, is going to ask us to find the area enclosed by f of x in this brand new g of x. Okay, so we're going to have two functions. You have this cubic, you have this line, and they're going to intersect somewhere, but that's great. However, what's nice is they're giving us two lines. These are going to be our limits of integration. To find the area of a function, you use integration. Now, if you're going to do two functions, what you're going to do is you're going to take the integral, lower limit, upper limit. You're going to do f of x minus g of x dx. Now, here's the thing. I don't know which one's on top. I don't know which one's on the bottom. I mean, according to this picture, it looks like the linear guy is on top, so whatever, who cares? If I get a negative answer, I'm just going to take the absolute value of it, make it positive, and I'm not going to lose sleep. So the integral that I'm going to write out is going to be the integral from regular 1 to positive 2 of f of x, so x cubed minus 48x plus 3 minus g of x, which is going to be minus 55x minus 3. Close it, dx. So that turns into the integral from 1 to 2 of x cubed. Negative 48 minus 55x is going to be negative 103x. 3 plus 3 is 6. Okay, now I can integrate. The integral of x to the third, and let's move that up here, is going to be 1/4 x to the fourth. The integral of negative 1 over 3x is negative 1 over 3 halves x squared. And the integral of 6 is 6x. And my limits are 1 and 2. So we're going to have gross math here that we're going to have to deal with. It's unfortunate, but it is what it is. Okay, so I have, let me make sure I have enough space. I don't know if I did a good job with that. 1/4, 2 to the fourth, minus 103 halves, 2 squared, plus 6 times 2, minus 1/4 times 1 to the fourth minus 103 halves minus, let me make that minus sign much clearer than it is, 1 squared plus 6 times 1. Okay, so 1/4 times 16, it's a close one, minus 1/3 over 2 times 4 plus 12 minus 1/4 minus 1/103 over 2 plus 6. So you become 4. You become minus 206 plus 12. If we combine these into one big fraction, I don't want to do it. I don't want to do it at all. Let's just do decimals. 0.25 minus, what would that be? 51.5 plus 6. All right, that first bracket, negative 208 plus 16 is negative 190. You become negative 45.25. Double negative becomes positive. So now we're looking at negative 144.75. So I did it backwards. No big deal. Our final answer is just make this guy positive. And by making it positive, we end up with 144.75. Yuck, yuckity, yuck, yuck, yuck. But that's it, and that ends free response question numero 4. Oh, yeah, I don't want to go backwards. A couple more to go, and then we're done this thing. All right, free response question number 5. We're almost home, kids. No calculator, that's all right. An open box is to be constructed from a 10-inch by 16-inch piece of cardboard. This is done by cutting out squares of side lengths x from each of the 4 corners and folding up the sides to form a box. Let's draw a picture. So we have ourselves a rectangle, yeah, and we're going to cut out 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4 squares out of each side, and each square is going to be x in length, x inches long in length. We'll call you 16. We'll call you 10. Now, there's my picture. You're welcome. Explain any domain restrictions for x, the length of the square cut from each corner. How do these restrictions ensure a valid box is formed? Well, basically what's going to happen is you're going to cut out these x's, and the restrictions are basically saying what x values am I allowed to use, right? Like I can't just say, oh no, I'm going to cut 15-inch, I'm going to cut 20-inch x's out of each corner because I don't even have that much information. So what is the smallest possible value that I can use? Well, for A here, the smallest possible value that I could use is 0.00000001. I can cut a tiny, tiny, tiny itty-bitty square and still have enough availability to fold it up and make myself a box with no top. So 0 is my smallest. Now my largest is found by taking the shorter side and halving it, but not equaling that. So if I wanted to, I can cut out sides or squares that are 4.99 and 4.99 and still have just a little bit of space to fold it up and make it the tallest, skinniest box known to man. So my domain restrictions are going to be x has to be in between 0 and 5. And the reasoning why is you must take less than half of the shorter side. Now, why is that? Well, because when you do cut out these squares and fold them up along these invisible lines, you're going to end up excuse me, I just get so choked up about these problems, I get excited. You end up with a box, okay? The height of that box is x because you're folding it up. You're folding it up. The height of the box is x. The length of the box is found by taking away 2 of these x's. So 16 minus 2x, and the depth, or whatever you want to call it, the width of that box is going to be doing the same thing, 10 minus 2x. We just don't know what x is. Determine the value of x that maximizes the volume of the box. Show all necessary calculations. Well, the way you use it, and by the way, this process is called optimization. The way you maximize or minimize an object is you take the function that can be created. Take the function of what you're trying to find. In this case, we're trying to find the volume. You are going to differentiate that. Take the derivative and find all critical points. You're going to use the critical points and also these points and find out which points are going to give me the largest value. So first things first, I need to come up with a formula for volume. Well, volume of a rectangle is length times width times height. So I'm going to do V equals x times 10 minus 2x times 16 minus 2x. This is just my volume formula. Okay, distribute the x. V is going to equal 10x minus 2x squared times the quantity 16 minus 2x. Okay, FOIL this guy out, FOIL that guy out. So let's be consistent with my colors. 10x times 16 is 160x, so V equals 160 regular x. 10x times negative 2x is negative 20x squared. Negative 2x squared times 16 is negative 32x squared. And negative 2x squared times negative 2x is going to be positive 4x to the third. Let's write this out in standard form and also combine like terms. So 4x to the third will go first. Okay, these guys combine to make negative 52x squared, and then plus 160x is lingering. Now what I need to do is take the derivative and set it equal to 0. So the derivative of this guy is v prime equals the derivative of 4x cubed is 12x squared. The derivative of negative 52x squared is negative 104x, and then the x just drops away. Oh, 160. See, no one will ever know. Let's move that up here. Set it equal to 0. Now, what I'm going to have to do is I'm going to have to factor that, and I should be able to factor out not a 12, a 4. I can factor a 4 out of that. When I factor a 4, it's still going to leave us with 3x squared minus 26x plus 40. So to find the critical points, we're going to have to continue factoring. This isn't going to get me anywhere. And looking at that, I don't think that's quadratic formula. Nope, it's going to be 3x minus 20 and x minus 2. Right, 3x squared minus 6 minus 20. Yep, so that'll do just fine. That'll do just fine. Now the critical points that I'll get here will be found by taking 3x minus 20, setting it equal to 0, adding 20, and dividing 3, and x is going to equal 20 over 3. Okay? Over here we get x equals 2. Easy peasy. Now at this stage you should be yelling at your phone or computer screen or however you're watching this and say, 20 over 3 is 6.6 repeating, isn't it? Which lands outside of the domain that you're allowed to use, which means you are not an option. You're not. So this is what I have to do. I need to take my endpoints here, and I need to take this critical point here, plug it into the original problem, and see which one of these maximizes the volume. And by doing this, it'll allow me to answer C at the same exact time. So we're going to plug in 0, we're going to plug in 5, and we're going to plug in 2 into this original volume problem. So now I can change colors. Now I feel comfortable changing colors. So V of 0 is going to be, I already know it's going to happen, 0. I'm not going to waste any time doing a whole lot of math. All right. V of 5 is going to be V, so that would be 5 times 10 minus 2 times 5, which is 10, times, you know what, who cares, because 10 minus 10 is 0, so you're going to be 0 anyway. Now, we knew this. We knew by plugging in 0, that's me basically saying, I cut out nothing. Now, I know 0 is not allowed, so if we just make believe that this is 0.00000000001, I'm going to basically get 0.000000001, and that's not going to be a big volume. Similarly, I know I can't cut out x's of 5, but I can cut out x's of 4.555555555, or 4.999999999, which would be a lot better. And if I plug in 5 and get 0, then plugging in 4.99999999999 is also going to give me 0 or something awfully close to it. So the only one here that's going to make sense is 2. So x equals 2. And how am I supposed to answer this? Determine the value of x that maximizes the volume. So x equals 2 is going to be my guy. So for part C, let's find out why. V of 2 is going to equal, let's use that formula right there, it just seems easier for me, 2 times 10 minus 2 times 2, which is 4, 16 minus 2 times 2, which is 4. That's going to get me 2 times 6 times 12, which is 12 times 12, which is 144. So the answer to part C is going to be 144 inches cubed. All right, so x is 2 inches for B. That's the value that maximizes it. And the maximum volume that we're going to get is 144 inches cubed. So this is the standard box with no top optimization problem. You know, I've been teaching calculus for a few years. I use this problem every year. It's very typical, very standard. Will you definitely see it in an AP Calculus problem or test or whatever? I don't know. But I like it, and so I did it. And that, ladies and gentlemen, is question number 5 for the free response problems. On to the 6, and then we're done. All right, my brothers and sisters, we're finally at the end. Problem 6. Given the functions f of x equals sine 2x and g of x equals cos squared 2x, answer the following questions. All right, calculate the instantaneous rate of change of g at x equals pi over 4. Show your steps. Instantaneous rate of change means the derivative at a point. So what I need to do is find the derivative of g, and then once I do, plug in pi over 4. Now g is cos squared 2x. I'm going to rewrite it like this because it helps me understand it better, because I'm going to be applying chain rule to this guy. So we have cos 2x squared. Now chain rule says that we take the derivative of the outside, which means we drop the 2 in front, right? Make that an invisible 1, which we'll clean up in a bit. Obviously, we have got a lot going on here. Keep the inside stuff, which is cos 2x, and then multiply everything by the derivative of the inside stuff, which, fun fact, is going to be chain rule yet again. So the derivative of the inside stuff is going to be negative sine, because we're taking the derivative of cosine. Keep 2x, but then multiply everything by the derivative of 2x, which is 2. All right, so what we end up with is g prime is going to equal, we can throw that negative out there, we can keep that 2 times 2, which is 4 out there, and then we have, since that's the invisible 1, cos 2x sine 2x. Now, I need to plug in pi over 4. So g prime of pi over 4 is going to be negative 4 cosine. Now, 2 times pi over 4 is pi over 2. Okay? And sine 2 times pi over 4 is also pi over 2. Cosine of pi over 2 is the same as cosine of 90 degrees, which is a big fat nothing. And sine of pi over 2 is going to be, well, you know, who cares, because all of this is just going to be 0. So the instantaneous rate of change at x or pi over 4 is 0, which means the tangent line is a flat horizontal line. Fun, 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 fun in the sun. Fun, fun, fun in the sun. Okay? Show your steps. I did. Let's go to B. Find the second derivative of f of x, denoted as f double prime of x. Show your steps. Well, f of x is sine 2x. The derivative with respect to x is chain rule. Take the derivative of the outside, which is cosine. Keep the inside, which is 2x, but then multiply everything by the derivative of the inside, which is just 2. So f prime of x can be cleaned up and turned into 2 cos 2x. F double prime is the derivative of what we just came up with. So 2 still lives there. Cosine is going to become negative sine. Take the derivative of the outside, keep 2x, which is the inside, and then multiply everything by the derivative of the inside, which is 2. So very similar to what we saw over here. Very, very, very similar. But this cleans up to f double prime of x equals negative 2 times 2, so negative 4 sine 2x. Okay? Show your steps. I did. I just did. Now onto the hammer. Okay? Calculate the area under the curve of f of x over g of x. So before we do anything, okay, let's find out what f of x over g of x actually is. And we'll do that over here. F of x over g of x is going to be sine 2x over cos squared 2x. Now that 2x is gold because that tells me we can simplify stuff. What I could do is I could rewrite that out as sine 2x over cos 2x. And then over here, I basically have 1 over cos 2x. That's what sine squared 2x means. I mean, I wrote it back in part A that it's the same thing as cos 2x, all of it squared. Now u becomes sine over cosine, which is tangent, 2x, and u become 1 over cosine 2x, which is secant 2x. So what it's asking me to do is calculate the area under that curve. Okay, so to calculate the area under the curve, that is going to be an integral. And we're going to integrate it from 0 to pi over 6. Okay, show your steps. So I'm going to integrate from 0 to pi over 6 tan 2x secant 2x. Now, there's a lot of ways you can handle this, okay? I just so happen to have it memorized that the integral of tan x, okay, and this is just a fun fact I'll write off to the side, the integral of tan, and we'll actually do this, tan u secant u du happens to be secant u plus c technically, but whatever. Okay, that's a little rule. So I know all of this will eventually become secant. However, that 2x is not x. I can't just apply that rule. So what I have to do is I have to do u substitution. So I'm going to let u equal 2x. Now this isn't that bad because then you do the du dx, the derivative with respect to x, and that's just going to be 2. And I need to find a way to replace that dx, so I'm going to multiply dx divide by 2, and then dx is going to end up being du over 2. So simplifying this a little bit, I have the integral, okay, as x goes to 0 and x goes to pi over 6. I have du over 2, so tan, first off, 2x is now u, so tan u, secant u, du over 2. Basically, pull the 1/2 out. So to pull the 1/2 out, my limits are still x is going to 0, x is going to pi over 6, and then I have tan u secant u du. And according to what I just wrote right over there, that is going to become secant u, where my x limits are still pi over 6 and 0. Let's substitute what that actually is, and let's kill 2 birds with 1 stone. I can bring that 2 back out, that 1 over 2 back out. Okay, secant is cosine, and u I called 2x. So I'm going to write it out like that. Okay, so what I do now is I'm going to plug in pi over 6. So 1 over 2 cos 2 times pi over 6 is pi over 3. And I'm going to subtract me plugging in 0. 1 over 2 cos 2 times 0 is 0, so cos 0. Cosine of pi over 3 is a half, so you're 1 over a half. And cosine of 0 is 1, so minus 1 over... Oh, did I forget something? I did. 2 times a half. Oh, boy. So 1 over 2 times a half, that would change things. Over 1 over 2 times cosine of 0, which is 1. So I get, and hopefully this doesn't get cut off when I make the video, it shouldn't, 1 over half of 1, or half of 2, which is 1, minus 1 over 2 times 1, which is a half. And when the all is said and done, I get 1 half. That, ladies and gentlemen, is it. That is the Math Teacher GOAT Ultimate AP Calculus exam, beginning to end, soup to nuts. I hope you enjoyed it. Share this with all of your calculus friends. Thank you for watching. I love you. Bye.